So now it's my pleasure to introduce Ivan Vladimir Mesa Ruiz, who is an associate researcher at the Computer Science Department in the Autonomous University of Mexico. So the floor is yours.
Thank you. I also want to thank the organizers and Luciana for putting us together and bringing us here. Also, it's a double thank you because I cannot think in other place where I could tell this short, long story about a Mexican speech recognizer. No. So why I gonna talk about a Mexican speech? I know it's sometimes a speech doesn't it's not considered part of NLP, but there is a reason why I think it's gonna be part. First, I want to talk about this because it's an example of a slow cooking research. It has been 19 years in the making, and we have seen a lot of projects, and they are very fast, and they are showing the timeline that Maria shows is from 2018. We have been working on this 19 years, and why it's taking us too long? Because you also have heard here that the region has some challenges. I'm gonna show you some challenges we have faced. We had made a lot of mistakes, so I also gonna talk about our mistakes. But I also want you to make you aware that the speech might be part of the next frontier for NLP, because we are working more multimodality, and there is going to be a wave of speech NLP. It's already happening. We have a speech translation. When we do, we listen the phrases and we translate it directly to audio. We have speech dialogue systems that you might have seen. There's going to be a speech summarization, the same thing. There is someone is talking, and there's going to be a summarized audio of this talk. So all these things are happening, and I think it's very exciting for all of us. We didn't start this work. Actually, this work started last century, last millennium. It started in the United States, where they collected several data sets. They included they were Latin American Spanish, but most of them were heavy on Mexican Spanish. They were released under the Linguistic Data Consortium. If you don't know, the Linguistic Data Consortium is an organization which collects data and is in charge of preserve it through time. They do an excellent work. However, to access these resources, you have to be subscribed to annually, or you have to pay for individual corpus. So what happened later is that other researchers start working on speech, on Mexican speech, and they created their own corpus. They created their own data because it was not possible to access the data that was already created. So I'm going to talk particularly about the last resources. We call it DMEX100. In Mexico, it's a very famous project in speech recognition. And what I can tell you is that there were some decisions that we took at that point that were not the best. The project took 5 years to develop. We only collected 5 hours of speech, which is very small. The previous corpus you saw, they were in the tens of hours. Here we are just in single digits. And it was because we didn't have access to the previous research. We didn't understand what was going on. What we needed to do a speech recognition, we didn't understand it. Usually what we need is a recording and an orthographic transcription of what is said in the recording. So we didn't know that. We started studying. We found that there was a lack of understanding of how Mexicans speak, so we started studying phonetics, we started studying phonology. We labeled the corpus. That's the reason it took us 5 years, because the corpus was labeled on these levels, phonetically and phonology. It's a very time-consuming. I tell my students, if you want to torment someone, you give them to label at the phonetic and phonetic level, because you are listening for little sounds, repetitive, and trying to decide which is the corresponding sound. It happens that we didn't need to do that. We needed the orthographic transcription. We had the orthographic transcription very early, but we thought we needed to do this. So we spent 5 years. Later, in 2017, this corpus was used for speech synthesis, which is perfect for doing a speech synthesis. But because we didn't know, we never realized it was perfect. We lost that opportunity because we were focused on this. It wasn't a loss of time because there were a lot of publications. We understand what were the fundamental sounds of Mexican speakers, and we make some progress there, but we didn't have a speech recognizer. We didn't have the time, the required data. Also, we decided to do read speech. That was okay, but because we saw that the previous corpora were closed, we decided our data to be closed. So the impact of the corpus was very limited for research. Also, we did some detours. At some point, we worked with speech, children's speech. Later, we worked with robot interactions. We only have 10 hours by that time of speech, and we were creating speech recognitions only using 10 hours. The system were not working. It was very frustrating to work with this system, particularly the children's system. The children complain a lot about that they couldn't speak to the system. No, they were very critical about the working. So by 2013, Carlos Hernandez Mena started his PhD, and he started in speech recognition. Fortunately, he had read some of our papers, so he contacted us and he said, I want to do a speech recognizer. I want to work on this. I'm going to start labeling it in the phonetic and phonological level. And we just were in time to tell him, no, you can start with the orthographic. You are only going to need orthographic transcriptions. So he took better decisions. He focused on spontaneous speech. We are going to see that this is going to pay later. He follows on an open strategy. He got licensed to redistribute the audios. He used a program called Social Service in Mexico, where students that do an undergraduate had to pay back society, giving 640 hours of work. So they were segmenting and transcribing corpus. He decided that the corpus will be part of linguistic data consortiums, but he manage a deal where they will be open and they will be freely available for everyone, while he also will be able to distribute it on his own website. So we have control of all the resources, and they are freely available. He also detected that there was a gender imbalance in the first version, so he fixed it with a complementary corpus. And now we have a balanced corpus, same number of female speakers than male speakers. And he later processed other corpora like Wikipedia, LibriVox, and TEDx. At the end, we have all this corpus. We were working on this from 2015 to 2021. All of them are freely available. There are different versions. Each one has a special niche of work. And through this corpora, we were able to access other corpora. At the end, right now, we have 944 hours of speech, which is, for us, is like incredible now. At this point, also, we had moved to Caldi. We started with the Sphinx, which was what I started working. Carlos specialized in Caldi, but we haven't arrived to the deep learning boom. The deep learning boom started in 2014. It took us 6 years to arrive to deep learning. We started using end-to-end architectures. Right now, we have been able to fine-tune two models. They are available in Hugging Face platforms. If you want to play with them, they are the QRs. And I told you, we focus on spontaneous speech, which is a little bit noisier, there is more variance, and we are starting getting good results with spontaneous speech. Most of the benchmarks are based on read speech. The numbers are incredible on read speech, usually low of 7%, low on 5%. Yesterday we saw a slide that it said 3%. Ours are not that low because we are with spontaneous speech, which is noisier, more variable. But we are through fine-tuning, we are reaching good results, and we are very, very happy in this stage, 13, 14 years later. So speech recognition has been tough. We spent all this time. We face challenges. For instance, we were very lucky in the 2 last years that we have the computational resources to train these models. Before that, that's one of the reasons we didn't jump to deep learning, because we didn't have the computer power. However, now speech is becoming accessible, particularly for Spanish. If you want to work Spanish speech, it's very easy now. You have our models, and there are also other platforms that have Spanish speech recognition. Again, this is because we are working multimodal, and most of the tasks of NLP we are gonna be starting doing it with the speech. You don't need to collect 400 hours. You might, yesterday also was mentioned that you might need 50 hours to do fine-tuning in a domain, but maybe you can do it with 5 hours. Your system is gonna behave well if you fine-tune with 5 hours. We are very happy at this point. We have enough data, we have access to computers, and we know the current technology, which also was a struggle. Like we changed 2 paradigms, from Sphinx to Caldi first, and then from Caldi to all the end-to-end architectures. Future work, we are gonna continue creating more corpora and data sets. We know the path, so we are gonna continue doing. We are focusing right now on error understanding to learn what kind of mistakes our systems are creating, and we're investing a lot of time. We are working with students of linguistics to understand if there is some pattern, linguistic pattern, phonetics or phonologic patterns. We focus on Mexican dialects. We are gonna be doing this. Maybe an invitation here is to do a Latin American coalition and have different speech recognizers for different countries. I think that will be very, very cool to have. We are also working on multi-party and noisy environment. That's a new frontier on speech. The more noise, the more people talking, is the more challenges the systems, the performance fails, so we are gonna work. And finally, we are gonna try to pass this to indigenous languages, which they are mainly oral, so we are gonna work on this. And that's all I had for you. Thank you very much.
Thank you very much, Ivan. It's great to see work on our local languages. So next we have Luis Chiruso.
Hello? Can you hear me? No? No. Hello? Hola. Hola. Ahora sí.
Eh,
Ah.
Luis Chiruso is an associate professor here at the Universidad de la República. He's part of the local NLP team. So we had before a representative of a Mexican NLP team, and now we have a representative of the local here in Uruguay, people working on natural language processing. As also Ivan was saying, they've been also working for quite a long time on these topics.
Yep.
So it's a pleasure for me to introduce Luis. The floor
Thank
is
you.
yours.
I want to thank the KHIPU organizers and also Luciana for inviting me to this. And I want to tell you, well, the title of the talk is Examples of NLP for Social Good, and I will try to give a succinct definition of what I mean by that. Luis Chiruso from Grupo PLN. We work here, Universidad de la República, just across the street at the Instituto de Computación. And here are the researchers that are part of the group. Some of them are here in the audience, so thank you for coming. Okay, so we work on a bunch of stuff. Some examples, for example, are NLP for legal texts, events and time expressions. We had a big project about making a question answering system for the COVID-19 situation. We worked a lot on subjectivity analysis, for example, in humor detection and analysis. And what I want to talk to you about today is about NLP for education and NLP for Guarani. So first of all, what do I mean by NLP for social good? So the short definition could be using NLP to address the needs of a community. And there are a bunch of tasks that might fall into this category. And the ones I want to talk to you about are NLP for education and NLP for low resource languages, in particular indigenous languages. So let's jump right in. Part one of the presentation, NLP for Guarani and how you all can help. Okay, so what's the deal with low resource languages? We mean that a language is a low resource language because it doesn't have much digital data to work with and to use machine learning systems, to train machine learning systems with it. In fact, most of the languages in the world are low resource languages because there are only a few languages that have that are rich on resources, for example, English and Spanish and Arabic and Chinese. But for most of the thousands of languages that exist in the world, there are not enough digital resources to work with. So this is the case, especially for indigenous languages all throughout the world, and there have been some initiatives to improve the situation. For example, America's NLP is an initiative for getting together researchers that work on indigenous languages of the Americas. We have collaborated with Ivan on this as well. So what about Guarani? Guarani is a South American indigenous languages. It's spoken mainly in Paraguay and the region, for example, Brazil, Argentina, and Bolivia. Notably not in Uruguay, and we are working on Guarani here, but it's not spoken currently in Uruguay. In the past it was one of the languages used by the indigenous people. And it's not an endangered language. It has many speakers. It has between 8 million and 12 million speakers, but it is a low resource because it doesn't have a lot of digital data available. And that is something all low resource languages share. Other problems that are also shared with other low resource languages are unstable orthography, and there are many variants, especially because of contact with other languages such as Spanish. Okay, so what have we done about Guarani? Since we started some years ago, we started really small, trying to collect all the data we could find, and we started contacting researchers from many places, especially from Paraguay, but also Brazil and Spain. And we started trying to build some resources, for example, a small Guarani Spanish parallel corpus, a small monolingual social media data set, a small collection of embeddings, a small WordNet version for Guarani, and also a small Guarani Spanish code switching corpus. All of these resources are really small. So let me tell you something about the parallel corpus we built. It has around 30,000 sentence pairs between Guarani and Spanish with the Spanish translation, and it's really small. I mean, you can do machine learning experiments with this, but they're really not enough for doing something that is substantial. but you can still use it to run some experiments. So one thing we found when we collected the dataset, it's comprised of many subsets that come from different sources, and we noticed that the different sources have like different varieties of Guarani. They were used in different ways. So we asked the native speakers to annotate them and try to find the different varieties or dialects that you could find in the corpus, and we found there was a lot of differences. There was one source that had mainly Jopara, which is the current Guarani spoken in Paraguay, and the others have a more pure version of Guarani, and there was also some mix with Yehia and things like that. And that is a problem that is shared with many low-resource languages, that the difference in varieties might pose problems for NLP tasks. And we mean, this is only Paraguayan Guarani. There's also Bolivian Guarani and Guarani spoken by different indigenous people, which are also different, and this problem only gets worse. So we also did some machine translation experiments. When we started this project, there was almost no resources on Guarani, and of course no usable machine translation system. But last year, Google published a machine translation system on Guarani based on a totally different idea. Instead of using a parallel corpus, they used monolingual data, all the monolingual data they could crawl, and train a system using that. So being Google, they have a lot of resources and they can crawl all the web, and well, they have a lot of money and we don't. So it's no surprise that they got good results with their system and we didn't. But if you can see the bottom right point, we have one of the metrics, we got it better with our systems. Even with our low resources, we got better blue metric on the direction Spanish to Guarani. Of course, Google will continue to improve their system, so this probably will go away anytime soon. Okay, so I was talking about Jopara, I mentioned it, and I mentioned that it is like a mixture between Spanish and Guarani that is currently used in Paraguay, and it's an example of code switching, that is using two languages that have been in contact together tend to merge in some way, and generally you have phrases like this where you combine. You can see that there are some words in Spanish and some words in Guarani, and it is interesting to see where they use Spanish, where they use Guarani. For example, Policía Nacional and Fiscalía are two proper nouns, so it would make sense to have them in Spanish, but Investigación Ámbito Penal, it might not. So we are currently running a competition, a shared task on code switching detection like this, and well, Tamar is collaborating with us on that, and well, it is a competition that you can also participate if you want. We will bring data, and you can train your systems to try to do this, detect uses of Guarani and Spanish, name entity recognition, and a novel task on the use of Spanish in this. Okay, that's it for part one. I want to go for part two, NLP for education, in particular about teaching English at rural schools. And this is an extension project. It means that there's always, in an extension project, there is always a community you are targeting, and you have to collaborate with that community in order to make a solution. So some context of the project about English teaching in Uruguay. The National Education Administration has this target of universalizing English teaching throughout the country, and so there are not enough English teachers trained for that in the country. So one possible solution was using Plan Ceibal, the infrastructure of Plan Ceibal, that they gave one laptop per child, and also provide video conferencing solutions in order to cover as much of the country as possible. But that's a problem in rural schools where bandwidth is generally low, so video conferencing solutions are generally not possible. Also, there are not enough English teachers to cover all rural schools. So the National Education Administration, ANEP, created a plan called Inglés sin Límites, where they, at the same time, they train the rural school teacher and the rural school students in English. The rural school teachers don't know English. The children, of course, they don't know either. So with the help of other English teachers, they do that at the same time. They train both of them at the same time. Okay, so what's our role in this? We contacted the ANEP, the Education Administration, and they said, well, any tool that would help them do their job would be excellent. So we decided to make a platform that we call Sina for building English exercises and games and activities based on texts in English. For example, our idea is that if a teacher wants to work with an English text in class, they can input the text into the system and it will generate crosswords and word searches on different activities, question answering exercises, etc. So of course, the output of the system, as all these tools are not perfect, they generally commit mistakes. The output of the system needs to be properly edited by the teacher if there are errors. Okay, so a brief history of how this works. We started with 2 undergrad theses where they created games and classical exercises such as crosswords, word search, and a battleship game. And for doing that, they relied on a definition extraction model. They also used input text, and they used many classical resources of NLP, such as post-tagger, named entity recognition, and a parser. They use rule-based systems and also embeddings that, well, they used it for doing a bunch of stuff. And then time passed, and we started incorporating more activities and more technologies. So in 2021 and 2022, we included question and answering exercises, language practice, reordering a story, and we started using machine learning and deep learning for this, but also rule systems. So the rule systems don't go away. I mean, you can still use stuff that you could consider like the old way of doing it, but it's still used. So around the same time, we also started contacting people from the information and communication faculty. So they started collaborating with us. They had a lot of more experience in English teaching, so they helped us curating resources and improving the resources we already have. So manual curation is also a necessary thing. And later on, that was until 2022, we are also working on other games and activities. So coming soon, we will have a Tutti Frutti game, and also using large language models and image generation systems. We are doing experiments on matching images and text exercises. So this is all coming soon. So as you can see, there are many things. We still use like old rule-based systems and post-taggers and parsers. Though those don't go away, and in the case of education, they're still necessary, not only large language models. So I wanted to show you some pictures of the visits we did to rural schools. As this is an extension project, it is necessary that our researchers and our students collaborate and interact with the rural kids and the rural teachers. So we have visited 18, we made 18 visits to rural schools between 2018 and 2022, and more than 50 engineering undergrad students and communications undergrad students have participated in these visits, and well, they always have a great time, and the feedback is always very positive, and they love working with the children and showing the tools, and this gives us a lot of great feedback for improving the tool and making new things. So that's all I had to show you today. Thank you. If you want to, thank you. If you want to know more, there are some links here that you can check for all the things I told you today. Thank you.
So thank you very much, Luis. That was a very motivating presentation with a lot of projects here. So now it's my pleasure to introduce.
Sorry.
Yes, that's working. Now it's my pleasure to introduce Tamar Solorio. Is that working?
Yes,
Yeah?
sorry.
Great. She's a professor of computer science at the University of Houston and also now at the Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi. She holds a graduate degree from computer science from Puebla, Mexico. So she's also originally from Mexico, as other speakers.
Thank you, Luciana, for the introduction, and thank you for inviting me. Super excited to be here, part of this panel. Thank you to the organizers as well for having me today. So today I'm going to talk about some work that one of my former PhD students did. So I'm just, enjoying the trip and talking about his amazing work. And it's about addressing data scarcity in sequence labeling problems. And so this has been mentioned already. You can hear me, right? Sorry, yeah, excellent. How data scarcity creeps in many different scenarios. It can be because it's an under-resourced language where there's no digital data available, but it's also, for example, where you want to change from a new domain and the new domain doesn't have labeled data. So it happens in many scenarios. And so my student work on how can we make it easier to do domain adaptation so that we don't have to label data again and again. So this is what he was trying to do. So the motivation for that is even when you have labeled data becomes stale, like the piece of bread that I show there, because we know that models need to be updated. With time passes, language changes, the topics that people talk about change, and so the model performance degrades. And instead of annotating more data, we would like to do something smarter so that we can leverage whatever annotated data we already have. And so that's the idea. We also know that when we are adapting language models to downstream tasks, performance drops because you don't have enough of the data of interest. And so this is what we have been working on. The specific task where we focus on is named entity recognition. So for those of you not familiar, named entity involves recognizing a piece of text, the words that belong to an organization, for example, a person or a location, and is very relevant to do name entity recognition because they tell us the what, the whom, and the where of things. So it's one of the tasks that we'd like to do for other high-level applications. So that's the task we focus on. The approach that we follow here is we want to do style transfer. So we are assuming that we have a source data set that has been labeled, that you have plenty of that, but your target data where you really want to apply the model is much smaller. And so the idea is how can we leverage that large amount of data? We want to use style. So if we can learn the style, and in particular we can learn to style transfer from the source domain to the target, then we can leverage the label data in the source domain. And so it's a semi-supervised transfer domain adaptation. I'll talk more about why it's semi-supervised. But what we're trying to do is our model has two parts, a generator and a discriminator. The generator is going to be first trained to do paraphrase generation. And so that's the one that is going to do our style transfer. We're going to use a pre-trained model that is going to be trained to do style transfer from one domain to the other and then from the other and back. And that's where we have the cycle consistent reconstruction. And we hope that if the model does well at learning to style transfer, then we can take our label data in the source domain and use the style transfer model to cast it to our target domain and then train our model, a regular NER model, on the combined data set and get performance improvements. We also use a discriminator that does domain classification. So like I'm going to show here, we use adversarial learning to train these models. And so what we do on the left side is our paraphrase generator model. This model is a pre-trained model. It takes a prefix that is appended to the input sentence where the prefix indicates the direction of the style transfer. In a particular case we're working out here, we're doing domain adaptation from news wire data to Twitter data. So the prefix will say something like, rewrite this in Twitter style, or rewrite this in Newswire style when we have the other direction. And so we train this model to do this paraphrasing, and then we use this model inside the cycle consistent reconstruction model, so that we map from one direction to the other. We take the input sentence, the prefix to indicate the direction of the style transfer, and then here we bring it back to the different prefix so that we go in the other direction. And we have adversarial learning here, so that the model is trying to predict one domain from the other, and we have adversarial learning here as well. I have more details of this in the paper, but this is the paraphrase model, and this is the cycle consistent reconstruction part of it. Now, we use a pre-trained model to do this in the generation phase. And in order to get rid of a lot of hallucinations and things that are not going to be useful in terms that things that are not consistent with the task. So remember that we're doing NER. So what we want to start transfer is labeled data. And so, for example, what we want is to make sure that we have valid sentences, so that we don't have a sentence where the label is inside an named entity where we haven't started the generation of a particular named entity. So we use constraint decoding with a prefix tree, and what we're saying is all the sentences have to begin with the beginning of sentence, and at this point you can either go to generate plain text and then proceed with general vocabulary for general text, or you can generate the beginning of an entity. And if you're inside the beginning of an entity, then these are your choices, right? And so that's how we get rid of a lot of generating data that is not going to be useful and we're going to throw away. In addition to that, because we're generating a lot of data, we also want to have a way of measuring, selecting, right? Generation is free. It doesn't cost us anything. We can generate a lot of data, but a lot of data is also can be crappy if we don't evaluate it carefully. So we do evaluation for consistency, adequacy, fluency, and diversity with pre-trained models that gives us a score with respect to language and all these qualities. And based on that, we rank the sentences that are generated, and we select the ones that seem to be higher quality. For the evaluation, the clear question number one is, does this help? How do we know if it helps? Well, we expect to see better performance with the data that was augmented when we use the augmented data in combination with our small target data set. But also questions number 2 and 3, what is the effect of different amounts of target data? Is it still useful to use automatically generated data? And what is the effect of different amounts of synthetic data? Again, because we can generate a lot of data, is it helpful or not? And so for the experiments, we assume that we have parallel style transfer data. This is where the semi-supervised part comes from, because we do have parallel data where we have sentences in Newswire and the transformation into a Twitter type of data, right? And they're parallel because we can see how one sentence will be mapped to the other sentence. But that data set is not labeled for NER. So that data set is only helpful for training the first part of the model to do paraphrase in the style transfer. And then we need to do the label data, right? So we hope that because we trained this model to do style transfer, we can incorporate it to the rest of the model and do the label data style transfer. So for the label data, we use the temporal Twitter data and onto nodes. So those are the two different domains. Onto nodes is mostly Newswire data, and Twitter data, of course. Temporal Twitter data is Twitter data. The base models for style transfer are a T5 base model, and for NER is just standard BERT model with a linear layer. So these are some of the results. I'm not going to show all the results because in the interest of time, but I just want to show some numbers so that you can believe me that it kind of works. So we call this low resource. The data we use, the source data, we have full access to the source domain. and then we transfer that, right? And we generate that we simulate Twitter data based on that. For target data, we only have 1,000 samples. The base model, like I mentioned, BERT plus a linear layer. The evaluation metric is F1 score because we're doing NER. And we compared our system against previous adaptive data augmentation approach that was state of the art, and our own previous model where we were not using parallel data. It's an unsupervised domain augmentation approach. So here we have the methods. This is where you only use your source data for NER. And this is going from a magazine domain to social media, and this is from Newswire to social media. And this is our approach, this is our previous work, and this is the state of the art. And this is where we are selecting 1,000 sentences automatically generated when we add 2K, when we add 3K, when we add 4K. And as you can see, all of the models do better than using just the source data, which makes sense because you have limited data. But as you can see, when we use our approach, the improvements are larger than with the other work. And here's a link to the paper if you want to know more about that. So, yeah, so I forgot I had this animation. But I already talked about that, so we can skip it. Okay. And we can skip it. There you go. Here are some sentences, example sentences for the model so that you can believe me that style is actually working. So, I mean, very quick signs that this is working. We have, emoticons that are introduced from one domain to the other one, and we have also like something that is funny, but we have some here, LOL, right? I mean, this is very simple, but signals that the style transfer is kind of working. We have more examples in the paper too. So concluding the findings that we have, supervised domain adaptation works. It's a cheaper way, and it allows us to reuse data that has been labeled, which is very expensive to gather. And so it allows us to improve domain adaptation. For future work, what we would like to do is explore multilingual settings and transfer data across languages. That will be super nice because, like we have seen, there are languages where we have very limited resources. And it will be nice to explore other downstream tasks. We only look at NER. Many thanks to my former student, Shuang Chen, and collaborators in this work. And last but not least, I also want to take opportunity to talk about recruitment. I am joining MBZ University full-time in the summer, and I'll be looking for postdocs, master students, and grad students. So if you're interested, please let me know. It's a nice opportunity. They offer a very nice package. And another plug, and echoing what Luis already mentioned, we have a very exciting shared task on Guarani Spanish. Please consider participating. You still have a lot of time. I think the test phase ends sometime in summer, so there's still a lot of time on that. And we have a workshop on code switching happening at EMNLP later this year, so also consider sending your work to our workshop. And that's it. So questions are going to come out later. So thank you so much for your attention. Thank you for having me here.
So before we start with the questions for our speakers, so keep them in mind, I just wanted to make two small announcements. One is that the next biggest conference in the American continent in NLP is going to be for the first time in Latin America. It's going to be in Mexico in June. So we expect everyone there. And we are very excited about this. So just that you are a bit more motivated. And something else, I wanted to tell you that the same organization that organizes that conference offers every year a Regional Americans Fund that is some small funding, around $3,000 for Latin Americans working on NLP. Also, the conference offers travel grants, usually partial travel grants and fee waivers for Latin Americans because we are underrepresented in natural language processing. So keep this in mind and apply. So that's it from my side, and now I open the floor for questions for all our four great speakers.
Okay, so thank all of you for your talks. My only question, the first question is for Ivan. I just wanted to ask you about the speech processing because I don't know nothing. I know nothing about that. How do you think? Well, how do you think that a particular Spanish variety like the Mexican one can be used to train or to transfer to other varieties of Spanish? Like, I know nothing about that, so I want your thoughts. Thank you.
Yes, it's not that complicated now. It will help if you have a different variety than the Mexican Spanish. You can use the model we have now, and you can fine tune it. And as I said, with 5 hours should be, and it should improve your variant, or the dialects at the level the dialects could be done. And it should help. It should be, right now it should be very easy to perform. These things are converging, and the experience we have now with large language models is becoming similar with large speech models. So it's very similar, and it will be possible to adapt it. It will be very possible to use it. The extra corpus I showed we got, they include other variants of Latin American. I remember it's Peruvian, Colombian, Chilean, and we use them together with the Mexican. Actually, our system is more like going towards Mexican rather than only Mexican Spanish. Yeah.
Hi, I have the microphone, so. I had one question, both questions for Luis, but one is maybe for all of you. I was intrigued about when you discussed Guarani dialects, that I would have imagined that the Guarani nation in itself was independent of the state nations of Latin America. So maybe if you can talk about that, why is there a Bolivian Guarani and a Paraguayan Guarani and an Argentinian Guarani? How that came to be? And the other thing I saw you had in your slides, and well, I know the things the Grupo PLN works, is to talk about hate speech, and maybe related with what Sarah Hooker said yesterday, and how the hate speech detector or the models they use in the US, for example, can or cannot be adapted to hate speech here, how race in our hate speech is different, or how other things came into account when discussing hate speech in Uruguay or in Latin America in general. Thank you.
Thank you for your questions. About the first one, I'm not a historian of languages, so we have a linguist that has studied in length the history of Guarani and how the migrations and evangelizations have shaped the different ways Guarani has evolved. And initially it was part of a large family called Tupi Guarani. I mean, it's still part of that large family that was spread all from like Rio de la Plata up to the Caribbean Sea. And Guarani was chosen by the Jesuits specifically because it was so widespread. Different varieties of the same language were so widespread that they chose it to use it as an evangelization tool. So I'm not expert. Ileana Rodriguez is the linguist that has helped us with this. And I don't know if the creation of the nation states later influenced the way that the different variants of Guarani are spoken differently. We focus only on Paraguayan variants, and there's still many, and they are not specifically the ones spoken, for example, in Bolivia or in Brazil. I know that the one spoken in Argentina is very similar to the Jopara variant, but I'm not sure how the rest came to be. We have contact with some Bolivian Guarani speakers, and it's quite different. We have seen that there's a substantial difference. So we want to collect some data on that variety next. Okay, so I already forgot the second question. Okay, so about hate speech, I didn't collaborate in that project in particular here in Uruguay. I know they collected a corpus of hate speech from Latin American tweets, and in particular from Uruguay. I collaborated in the annotation, and I remember it was awful. I mean, reading all those messages and trying to tag them was already awful. So I said, okay, I'm not going to participate in this anymore. But yeah, about the question, you mean if the techniques and data used for hate speech and recognition in English could be used for, okay. I think that using the current multilingual models, it is possible to do that style of transfer learning, and it would work, but up to a point, because there are so many regional subtleties that something that could be considered hate speech here might not be in Argentina or in Mexico, and the other way around. So we have to have a lot of care with that, and it's not that simple, I guess.
Okay, thank you so much for this wonderful presentation. I have a question to the four speakers, so if you could briefly answer. Being a linguist myself, I would like to ask you, what do you think are the main challenges in this relationship between linguistics and computer science for doing NLP? And you talked about errors and lessons learned. So what are the main lessons learned for you doing NLP? Thank you.
Maybe Tamar can start taking this one.
Yeah. Thank you. That's second is harder. The first one, I guess, is easier. Linguists and computational linguistics, right? So I guess definitely we have to acknowledge that it has become harder these days to see how we can work together, right? Because these bigger models, we went from a place where we were doing speech tagging and parsing to just do large pre-trained models and forget about the rest. I don't think that linguistic knowledge is not needed. I think right now we are just narrow-mindedly looking at, because we have seen great performance improvements. I'm not saying it's all bad, but I'm saying that at some point we're going to go back and figure out the things that are not being solved successfully with these large pre-trained models, where then we're going to have to bring back our linguistic knowledge. But so I think we don't have to wait, right, for the big wave of people to realize that. We can start ourselves with figuring out where that linguistic knowledge is still needed and how we can interact more together.
Yeah, I think we have to improve the relationship between linguistics and what we do, natural language processing. It's a tough task. I think also we are in a different stage, as Tamara was saying. From natural language processing, we can produce interesting data for linguistics as well. We have better models that are giving insights about patterns. So also I think that will be a way to bridge this gap between the two areas. Like we start understanding the problems of linguistics, we start giving data. A little bit what we want to do with dialects, it has to be, because we have linguistic questions about how Spanish is spoken in Mexico, and that's a product that has to be analyzed by linguists. So I think we can go the other direction, and now we give you data, and you can come up with hypotheses, theories of what is happening.
So I agree with what Tamara and Ivan said, and I want to add that I totally think that linguistic information and features are going to make a comeback, and they will be useful again. It's not that it's going to be large language models forever doing everything, because these large language models, we know sometimes they work very well, and sometimes they have a lot of mistakes, and we have to understand why. And linguistic knowledge and meta-linguistic knowledge is very important for this, to understand how it fails and what can we do to improve it. So yeah, it's not that linguistic features and information is going away. I mean, it's going to come back.
Yeah, so I agree with everyone, actually. I mean, I guess following up on something that they mentioned is that, like, yeah, so we kind of are tending towards specialization. And so maybe you can think of how we can bridge this gap. Another way is if the programs, like, you know, the undergraduate programs or maybe masters that are about, like, the computer science masters, maybe could incorporate, like, linguistic knowledge as well, like courses. And then I think that would be very helpful, and it would enrich, like, our knowledge, because I agree that we are maybe diverging a little bit. But I mean, usually not only in this field, but in other fields, what we've seen is that, like, you know, you had like the previously to deep learning, people were more theoretical, and then now we are in like the deep learning way. But then it kind of goes and comes and goes. So I think we will go again to that phase where we need to really look at the data and understand more what's going on. And so, I mean, another comment is that even though we are relying on a base large language model, I mean, one of the things I wanted to show you with my talk is that not everything is solved, and that also it is complementary. So essentially one example is the usage of tools. With the tools, like the retriever, you can help the model not hallucinate and produce more factual information. So you could think of building a different tool that will help you to, you know, understand more like the linguistic structure or any other knowledge that we know that it should be there, and then help the model correct its output. So I definitely think there could be ways in which we, like everything we can both collaborate, let's say, and then find a way in which we bring back that knowledge that we don't want to lose about like the classical linguistic knowledge. Yeah.
Thank you. Well, I have. Should I go first?
Okay, there's a question right in the back that we will take because it's been raising a lot. Yeah, next.
Yeah.
Yeah.
So I'm going to repeat the question. Rodrigo asked if there's always a human, if I understood correctly, in when generating English exercises, if there's always a human after the exercise is generated and before they arrive to the children, in order to check that there's nothing strange in the data. So the short answer is there should be. I already mentioned that the idea of the application is that you can generate exercises and the teacher can always edit them because there are mistakes, there are things that are wrong, so the teacher should be able to edit everything. But the long answer is that in fact we have another module that generates random exercises in a way not based on a text, and children can can create and use them freely. And that data is more curated, so we don't use large language models or we don't extract information from text. So there are fewer mistakes, we think. It's manually curated and it just combines random things. And so in theory, there shouldn't be many mistakes in those exercises. But for the real thing that uses input text and tries to extract things and generate more, there should always be a human overview of what happens.
Thank you for the nice presentations. I have a couple of questions for Ivan. The first one is related to what kind of metadata are you gathering when you build your data sets? And the second one is, have you implemented any kind of active learning-based tool to speed up the annotation of the data that you have gathered?
About the metadata, we try to anonymize as much as possible the speakers, but we usually have the nationality. We have if it's a female or a male in this binary division, and that's basically what we save. And we have the transcription, depending on the exercise, there is orthographic transcription, sometimes more standard Spanish, written Spanish, and sometimes we try to capture dialectal variations. So that's all the metadata. About active learning, no, we haven't used active learning. That's an interesting path that at some point we are trying to go in that direction. We just using the speech recognizers we have, label new data, and then ask to reviewers, depending on our confidence. We have thought about that. We haven't set up an environment. If someone wants to help us, we are happy to collaborate.
Hi. As a linguist, I am going to take up Andrea's question, and I would like you, I think my idea is that humanity has to agree on a set of values, and probably what we feel from the linguistic, more qualitative part is that errors are not being valued enough, that when we report performance in the area, we report the numbers of performance and we do not dive into the quality of errors, and some of those errors are really unbearable. They are not something that we want. So I would like Maria, who has, as I understand, has looked into the limitations of the language model. If you could tell us a little bit more about the limitations so that we do not have to wait, like Tamar said, and begin work now on those limitations before something really awful happens?
Yeah, I guess, first of all, I completely agree with you that we know that deep learning models can have very big blind spots, and whenever they fail really bad. So that is, let's say in general, it's not specific to NLP. But for example, if you have a self-driving car, you don't want it to go and crash, or when it has to take difficult decisions. So in this case, let's say, compared to that, maybe I guess we've seen that deep learning has helped solve some of the tasks. So, well, I guess my answer to you might not be satisfactory, but for example, what we realize is that knowledge is indeed encoded in the parameters of the language model, but then there are some tasks that are, let's say, easier to solve that are outside the knowledge that is there, like it's bundled there. So for example, for math, even just having a calculator makes a difference. Or for example, also there's a tool that we are using with the base language model that is useful for doing machine translation. So far I'm like, we only have explored tools that are other tools that have been around in like more like NLP from the computer science perspective. But what I'm thinking of is that possible extensions could incorporate more like what we know are failures from the large language model into a tool that will make use of linguistic knowledge and that could help correct such failures. So I think this could be very interesting. I don't really have, like, that's my like high-level description of how I would do it. But yeah, I think definitely, and I mean, if you want to chat more about it offline, like, I would love to hear it.
Great.
Yeah,
Great.
thanks.
¿Le doy? No. Okay, I have a question for Maria. Quick. No?
If someone else was there waiting for a long time, can... Oh, okay. No, yeah,
Okay.
you go.
So I like the idea of the atlas, and you mentioned a lot like Wikipedia, and I was wondering how you could translate this to languages other than English. Like it looked like the large language models, like we are always so back behind, and even if Wikipedia works better for English, we have it in so many languages. So is there some hope to get better performances for languages other than English?
I mean, yeah, definitely. I agree that like Atlas was trained on English text only, but then there's many other efforts that have been working on language models for other languages. And both, like, obviously, like if you have like a high resource language like Spanish, English, French, or German, then you would be it would be like you would expect to have good performance. The challenge is like the low resources languages, like some of the examples that have been mentioned by my colleagues in the panel. So I mean, long story short, I would say the issue is that I think there's hope. So if we gather enough data, but then like the issue with deep learning is that you need lots of data. So for low-level languages, you do need maybe alternative things. And also it depends on the task, right? Because for machine translation, there had been like lots of good work, recent good work that works well even with low resources. But if you want to do like knowledge intensive, maybe it's a little bit trickier. So it really depends on the task. I wouldn't expect like you would uniformly do well in all the tasks depending on how available is the language. But yeah, probably other people in the panel are more knowledgeable about that than me. Like, unfortunately, I have like limited experience. I've been working a little bit with machine translation recently. But yeah, I think like, for example, Spanish is a very good example of something that has a lot of nuances. So would you like take all Spanish text? No, without distinguishing between like Spanish from Spain, Spanish from Mexico, Spanish from like any other country in Latin America, or would you train like separate models? So yeah, I think like there's lots of interesting problems in this area, but I definitely think that we at least have some tools to address some of these problems.
Hello? No? Does it work? Hello. I'll scream. So this is a question again for Maria. Sorry.
I have the next one.
Hello? Okay. So this is a question again for Maria. Sorry, we're making you talk a lot. So the question is about this retrieve followed by generation process. So usually when you do a Google search on some topics, you get contradictory information, either because there's no consensus or because it's a hot topic and people have different opinions. So what does the model do now, and what do you think it should do in that situation?
Yeah, that's a great point. So what we've observed is that depending on the corpus that you use, you would run into such problems. So for example, if you use something like Wikipedia that is, let's say, you could think of it as being more or less self-consistent, then you don't have that much of that problem. However, when you move to something more like Common Crawl, then you start moving to such problem. And then this is also to say that data curation is as important as running your model. Because you want to have strategies that allow you to use trusted sources. So the difference between a retriever and the search engine that Google has is that also Google has a way to rank high quality sources from low quality, and the retriever doesn't have that. So as you say, it only operates using a similarity search in the space of embeddings. So as you say, you could find things that are very similar in the space of embeddings to the query that have contradicting information, but they are in the top K. So the model would just attach them to the context. And it should not do that.
Right, because what would then generate something that is inconsistent? If the two sources that it's using are inconsistent with each other, what does it generate?
Yeah, I don't know. I think that's a good experiment to do. Probably it will choose one over the other or something, because essentially another thing about similarity search is that it's imperfect in the sense that you're scoring your top K with the similarity score, for example, inner product or L2. And sometimes, depending on the precision that you're using, you are not really obtaining the true order. So yeah, long story short, I think I haven't done that experiment, but I think it would be a very interesting one to do. And two, I want to highlight, as you say, there are things that that should be taken care of, for example, what sort of corpus you're using and how do you rank the fidelity of your sources. Not all sources should be passed to the language model. So yeah, I think you have great points. Thank you.
Hi. So here.
Yes, okay.
So I
One
want to
last question, because we don't want to go over time for the others.
I wanted to start by congratulating all the speakers here. It's been great research, really, and all the groups behind them that I'm sure are also here, some of them. So my question was very in line with this last question that we just had. So my understanding basically is that now you use a large language model to embed a question, and then you use those embeddings for retrieval. So you're basically doing KNN at a large scale, so probably ANN to be a little bit more specific. So I wanted to ask you, basically my understanding is that for the retrieval part, you just basically do this similarity search and then produce a context and give that context to the language model and basically ask the question that you want it to respond. So it's basically constructing a giant paragraph with all the sources that you've found and send that to the language model, hope that context length is enough, and then hope for a good answer that is less prone to hallucinating. So are there different strategies for computing these embeddings, or are you using the same model? And something else that I've seen a paper that actually says, instead of embedding the question, ask a language model to generate a potentially fake answer, and then embed the answer, and that will lead to better results at the end. So if you could talk about a little bit of the strategies for the retrieval part.
Oh yeah, great question. So I'm not aware of that paper, but maybe you can tell me the citation later. Okay, so first of all, yes. So we use a specific embedding model, which is the contriver, for initializing the retriever architecture, and for the language model we use T5. So I briefly mentioned that essentially you want to use, you pick this model to initialize your model because you want it to be already good at a retrieval and to have already good representations. However, we further train the model during the pre-training with using math language modeling to make it even better. Then second thing is, yes, so we do KNN and ANN. whenever the search gets too big. And here is like maybe a plugin that we are using Face. This is a library that was created in Meta as well. And so we have like very efficient similarity search for this step. And precisely that's how you can also pick the compressed indexes, because the product quantized indexes are available in Face. And I encourage everyone to see the repo, and then you can play around with different product quantized indexes. And yeah, so okay, so the other question was about the paper. So can you repeat what the paper does? I forgot.
So yeah, the paper says that instead of, when you're doing retrieval, they got better results by, instead of embedding like, what's the weather like in Uruguay, just ask GPT-3 or whatever to produce an answer that is potentially a hallucination, and then embed that answer and retrieve using the embeddings of that potentially fake answer. And that is closer, that will get you closer to the good answer in the text when you're retrieving.
Yeah.
So I don't remember the paper, so I had to find it for you.
Actually, I know which paper you mentioned. It's called something like generate and then retrieve.
Okay.
They kind of flip the order, and I mean, okay, there are many ways in which you can like incorporate the retriever into your language model. Then I guess you can say there's more than one way to avoid hallucinations. In our case, I mean, the knowledge-intensive tasks show that for factuality, it improves compared to just generating from a language model, right? So let's say that this is one possible way in which you can control for the hallucinations. The order in which you do the generation and the retrieval might be different, but I would have to look at the paper, because as far as I remember, they didn't compare to Atlas in terms of like some of the tasks. So there are different narratives. So I mean, I think there's a lot of room for other types of work, like for example, what you mentioned, also other different embeddings, like some people use Colbert, some people use BERT. So there's a whole area around the retrieval augmented language models. And I just finished quickly with the caveat is that using a regular language model is 10 times easier, because you can just go to Hugging Face and load them. And then with retrieval augmented language models, you have to actually do some work to modify the architecture. And that's why they haven't gone like very big, let's say, as LLMs. And that's why you can just use something out of the box and move fast. But then these ones are a bit tougher to work with, I would say.
Thank you.
Well, thank you very much. I mean, that was a very interesting discussion. Let's thank our speakers again. They were really great now, and I hope to see all of you in Mexico next year. And now we have the coffee break.
Great. So thank you all for coming. This is the Ethics in AI panel. As you can see, the format will be a little bit different from other sessions. We want this to be a conversation so that we can all go back home with some takeaways that apply to our everyday practice and the way we envision our field in the following years, or at least to have some questions, some relevant questions to consider. So we would really, really like this to be a conversation. That's why we have made it a little bit more dynamic. So first, each one of the people here will explain a little bit about their expertise in the ethical questions in artificial intelligence. They come from very different sides of the question. It is a very complex question. This is what we all say when we think about ethical questions. Most of all, when we are thinking about a concrete situation, say, this is complex. Yeah? And you wish you had some more perspectives. These people are here to give you some more perspective, to give us, and you are here to give them some more perspective. So we hope that this actually happens. So first, they are going to talk shortly, then they are going to comment on each other's interventions, and then we expect you to ask questions, and then since there's lunch and in the evening there's a party, and then we have many other opportunities to continue this conversation. We hope that we can actually do that, continue this conversation. So I'm going to introduce the first speaker. This is Paola Ricaurte, who is a professor in the Department of Media and Digital Culture at the Tecnológico de Monterrey in Mexico. Yes, she's also a faculty associate at the Berkman Klein Center for Internet and Society at Harvard University, for people who care about these credentials. And she's also a co-founder of the Tierra Común network. She coordinates the Latin American and Caribbean hub of the Feminist Network for Research in Artificial Intelligence, who has given many of us the opportunity to think differently and to free ourselves a little bit from mandates that we didn't align very well to. So, Paola?
Hi, thank you, Laura. Thank you very much to the organizers of this amazing event. It's been an honor and a pleasure to listen to all your projects and everything that you're doing. It's just amazing. I want to begin, I would like to start saying where I come from, where I stand, and what do I do. I am a social scientist. I studied linguistics in a time when it was not very fancy, like today. And I'm academic activist. I work from a critical, feminist, intersectional, decolonial perspective. And for many years, I have been researching the relationship between technology and society. More specifically, how technology is a fundamental element in shaping the relationship between power, knowledge, and, in this case, gender. So, although I live in Mexico, I come from a very small country, Ecuador, like many Latin American countries, is experiencing many forms of violence. So today I'm speaking in a personal capacity and not on behalf of any other institutions I am affiliated with. So the first question that Laura was asking us is, what about ethics and the social impacts on AI? And I decided to begin with a general framework about the ethical debate, the international ethical debate on AI. Because, for example, over the past few days, I have been listening to many of the problems that you face as a community. There have been discussions about model optimization, efficiency, decision-making. And I see that you spend a lot of time thinking how to make your models work. And my work is related to see what happens if your models work. For example, in the case, I don't know, we can have very optimal models to be used in automated weapons, for example, against immigrants in the border. But I also work to see what happens when models do not work. And in many international spaces, this discussion is framed in ethical terms. So there are more than 2,000 ethical frameworks around the world, and many of these frameworks have been developed by industrialized countries. Many have been developed by corporations, and others have been developed by international organizations, and Andres will speak more about that. But the thing is that ethical frameworks are not enough. Because ethical frameworks leave a lot of space for interpretation. They are no law-abiding. So many critical scholars from critical data studies or critical technology studies propose to broaden the debate about the social impacts of AI in general terms, machine learning in particular, not only in ethical terms. So I think that we should consider ethical frameworks to consider harm in a broader sense in terms of what happens to the bodies and territories that are impacted by these machine learning cultures and machine learning technologies, because usually it's difficult to trace back the cause of harms, and they fall into a void. So we want to talk about AI and power, and also from the point of view of human rights. We want to think of human rights not only as human, but we want to also expand the idea of human rights and include, for example, nature's right. The Constitution of Bolivia and Ecuador, for example, grants nature rights because nature should also be defended. So we want to think about rights in a broader sense, including cultural rights, including cognitive rights. So why do we think it's important to change the framework? There is a Brazilian scholar called Rodrigo Chigami, and he says that AI ethics is an invention, a corporate-driven strategy to prevent smart technologies from being regulated in a way that would limit their expansion process. So this general international discourse on AI ethics was strategically aligned with the Silicon Valley effort seeking to avoid legally enforceable restrictions on controversial technologies. So talking about trustworthy, fair, or responsible AI, he says, is problematic, meaningless, and whitewash, because it ultimately serves the goals of the global political and economic elites. As a result, corporate ethical discourses, particularly those emanating from countries with complete control over AI governance, may be interpreted as a Western ethical white corporate washing. So critical studies on data and algorithms, intersectional decolonial feminist studies, critical race theories, indigenous and ancestral epistemologies, are offering alternative analytical perspectives that allow addressing the genealogy of the problems anchored in the imaginaries, development, and deployment of machine learning algorithms as a social technical construct. So we are trying to refocus the debate, because this is not only about creating narratives and imaginaries, but also there is a lot of investment from corporations and countries in industrialized countries, which see in AI a fertile ground for capitalist accumulation and the expansion of the military capacity of states, the expansion of trans-territorial political influence, and the capture of the imaginaries of societies to impose a world model that is associated with the values of the market, modernity, and neoliberal freedom. So I will finish now. So when a group of authors say that AI's trajectory in society is not simply a question of whether humanity will benefit or not, but rather of who will benefit. And unfortunately, until now, AI is a technology of privilege. AI is reinforcing the wealth of certain countries and corporations. AI technologies are also technologies of racialization, genderization, and social classification, not only in local terms, but also in global terms. And AI technologies are also part of a very strong movement about who decides who can live and who can die. And we have seen this in many, many examples around the world. So I just wanted to begin just putting out this discussion about ethics and AI and why it's important to reframe the discussion about ethics or ML cultures or AI in general in terms of human rights, but in human rights considering all the aspects of human rights, not only being human, but also the relationship between humans and not humans. Oh, thank you.
Thank you. Thank you, Paola. It's always so enlightening to view what you do every day in a different perspective and bring relevant issues and relevant concepts into the thinking and framing of what we do. So thank you for opening this, broadening the discussion. Now Sasha will be focusing on some aspects of what Paola has said. Sasha Luccioni is a research scientist at Hugging Face, where she works on the ethical and societal impacts of machine learning models and data sets. She's also a director of Women in Machine Learning, a founding member of Climate Change in AI, and chair of the NeurIPS Code of Ethics Committee. And she's focused on measuring and mitigating the negative societal impacts of machine learning in many domains, different domains. Yeah, I know you know what you're going to talk about, but I always have a question. Very often we hear that AI optimizes things, so it is beneficial because of this optimization, but we do not hear so often what the cost of this optimization is. No? So I would like to hear what you have to say about that.
Sure. And actually, you mentioned Climate Change AI. It's an organization of AI practitioners, researchers, industry, and academia who are worried about climate change and the climate crisis, and who essentially have come together. We organize workshops, we do research projects, we publish papers, and we try to focus on the positive. We really do. But everything has a cost. And as Paola mentioned, the cost to the environment is often downplayed because people see AI as this very immaterial thing. That's something that's trained on a cloud. That's something that's running. Siri, where is she? Where is it even existing? Right? AI is not something that has a form, a physical form, and so people think it doesn't have an impact in terms of resources, in terms of emissions, but in reality it does. And a lot of the work I try to do is trying to piece together the puzzle, because I focus on environmental costs. I see this as part of the ethical impacts of AI. Because ethics and sustainability, ethics and justice, climate justice are very tightly linked. So there's been a lot of work, for example, in terms of making efficient machine learning models, but it's often reported as flops or computations or hours sometimes on a GPU. But that also comes with an energy cost, and depending on where the energy was generated, this can have a very big impact on the emissions of the model. So to give you some general figures, a model like GPT-2, a couple years old at this point, it's estimated that it generated 500 tons of carbon emissions, of CO2 emissions, And this is equal to more than 250 times more than the average Uruguayan emits in a year, just for context. So this is a lot of carbon. And GPT is an older model. Models have gotten bigger since. And so currently we're talking about 1,000 tons of CO2 sometimes that gets reported. And you know, this is even just the tip of the iceberg because, for example, making a GPU, making hardware to train a machine learning model takes a lot of water, takes rare earth metals, takes you know, transportation between countries all over the world in order to put together these very efficient computers. And we're changing them every couple of years because we want the best GPU. A100s, you know, become V100s became A100s, and we always want more. And now, for example, training AI models requires around 2,000 GPUs, for example, running for several weeks. So that is a cost as well. And that's something that doesn't get reported either. So it's estimated that the production of a single little GPU chip is also around 500 tons of carbon, and we're using thousands of them. And so all of this adds up, and it kind of gets swept under the rug. And why do I think this is linked to ethics? Because ethics is really hard to measure, it's hard to quantify. There's different ways of doing so. You can do it by, for example, comparing the impacts on different populations. You can see, for example, when someone gives loans using AI, you can compare different groups and say, well, this group received, you know, got these many rejections, this group got these many dollars. You can try to quantify it in different units. And for me, carbon emissions are one of the units, or I mean, sustainability more broadly. You can use different units for calculating, right, the cost. But this is also an ethical question because it also touches upon things like accessibility, right? Like who can actually afford 2,000 GPUs for, you know, 100,000 hours? Not very many people, not very many organizations, not very many countries, not very many continents. And so when we start measuring costs, it could be in dollars, it could be in kilowatt hours of electricity, it could be in tons of carbon. When we start measuring costs, we can start comparing. And we can start, like, we recently did a study of 100 recent machine learning models, and when you plot them on a map where they were trained, it's always the same story, right? Europe, North America, there was one model trained, I think, in the Middle East, but otherwise, there's whole continents that get left out. And you know, the article was more about the environmental sustainability, but you can start connecting the dots and saying, well, these are the same patterns. These are the same patterns of, for example, climate change in general. Who's responsible for the emissions? Who suffers the consequences? And so yeah. So I guess I'm particularly worried about the evolution, where this is going, because especially large language models, they're getting bigger and bigger. So right now we're talking about 100 or to 200 billion parameters, which is huge, right? And we're still in a race of having the biggest model, and that's kind of a worrying thing. I started in NLP around 10, 12 years ago, and we were kind of more focused about trying to solve a task, trying to, you know, extract some words, some entities, trying to predict some classes, and now we're just like, people are literally adding 5 billion parameters just to say they have the biggest model. And then that particular direction, I find, is very counterproductive. And so the work I do at Hugging Face, we work on model documentation, because in order to start measuring impacts, you need data, right? And oftentimes when people publish a model, they'll just say the model has 95% accuracy on these data sets, and that's it. But you know, we ask questions like, what's the data? How long was it trained for? What hardware do you use? So we create model cards. We ask people to fill them out with all the necessary information to reproduce, for example, results. So, you know, you say you get 95%. Can I reproduce that figure? Is this a number that I can verify? That's kind of important. We also try to evaluate data sets. So, you know, sometimes people share data in, you know, some zip file in some Google Drive somewhere in the world. So we try to get that data and get some statistics on it. How many words does it have? What kind of words? What are the top words, for example, for text data, right? What are the top classes? So all of this to help people understand what they're putting into these models and what they're getting out, because it is linked, right? Because nowadays we're trying to get the most data possible, hoping that it's going to get the best performance possible. But what's in that data really affects that performance. And so we're focused on open source, we're focused on efficiency, for example, distilling models in order to make them run on smaller hardware, things like that. And I think that this kind of work is important, especially when everything is shared, right? So every time we create a model or we document a data set, it gets put up right away and anyone can access the information or the model. So hopefully by being more transparent, we're not at the point yet where we can say we're going to cap AI emissions. Currently, we can't say, like, you can't train a model that emits more than 100 tons. We're not there yet because we don't have enough numbers. Because I think maybe other people will talk about this, but policymakers need numbers in order to say, okay, this is a very polluting model and this is a very sustainable model. For example, if you want to have a spectrum, you need numbers. And so currently we're at the point of transparency, so better documentation, and hopefully once we get enough information, once we get enough data points, we can start actually assigning scores or capping or controlling the development in AI in a way that goes towards more equity, more sustainability, as opposed to just bigger models that pollute more. Thanks.
Okay. Thank you. Thank you, Sasha. So now we have some concrete action item for everyone to take home and do the homework. Yeah, that's good because it actually connects directly with what Paola was saying. I guess some of you, at least it happens to me when we hear what Paola has to say, okay, I agree. How do I do that? So we are beginning to bridge this gap between the general principles and how to do that. And as Sasha was saying, policymakers try to help us with that. Someone said yesterday that what we have to do is, as a whole, come to an agreement on values. I agree with that. This is the people who have been doing this for a while. Andres is a specialist of the social and human sciences sector of the UNESCO for Latin America and the Caribbean, and the program for ethics in science and bioethics. He's a lawyer and a journalist, so he's making a big effort coming here. I hope we, yeah. And a Chevening scholar with a master's degree in social policy and development from the London School of Economics, for people who care about these credentials. He's a former director of the Foundation for Press Freedom and has been a consultant for different international organizations, many that you can ask him about, really, really interesting. So I hope you help us because we know that we agree on doing good, but it is difficult for us to know how. Maybe this comes more on the practitioner side, but then we are also in situations where there's a matter of incentives that we do not have the tools to deal with, and we often come to the final sentence. Okay, this has to be regulated.
Okay. Well, good morning. Thank you very much, Laura, KHIPU, everyone, for this invitation. I have to say that I feel a bit intimidated because I'm more used to work with policymakers rather than researchers and practitioners. So part of what I think should be important after this event, it should be to build bridges between what you are doing and what policymakers are doing, because that's part of the discussion that you need to be involved. So first of all, I want to give just a brief introduction. You could say, well, what has to do UNESCO with all this? Well, UNESCO, for those of you who doesn't know it, is the UN agency that had the mandate to promote ethics on the science and technology, and that's part of what I'm responsible of in Latin America and the Caribbean. And I'm responsible of promoting the UNESCO recommendation on the ethics of AI that I will introduce you and share some information. So basically, as Paola and Sasha said, well, in these AI discussions, there are many risks happening. There are a lot of opportunities, but also some risks having to do with reinforcement or reproduction of inequalities, of biases, of discriminations. And that's part of the discussion we need to have and to do to make action. And some of them happen because we don't tend to do some basic questions that appear to happen, or we appear to respond when the damage has been caused. But we should try to begin by asking some very easy questions, such as how diverse is the data that we use? For example, in a continent like Latin America, where the 8% of the population is indigenous, we know that there are some biases and some discrimination on the data that we use that don't include them. And that's part of how we can keep opening and making and reinforcing the discriminations against indigenous people, or how transparent is the algorithm that we are using, or who is responsible when a harm or the damage is caused, who is going to respond, who is accountable afterwards, no? Who governs the AI, who controls it, or who should control it. So those are questions that should be happening through all the AI process. We are used to say in UNESCO, we should have an AI ethical by design. That means since the beginning and until the end, during the whole process. So policymakers are worried about AI, are worried because they don't know the topic very much, because it's happening very fast, and policymakers don't go that fast, and because they know that it brings opportunity, but it's also bringing risk in terms of human rights, in terms of environment and climate change, in terms of gender equality. So it's a discussion happening at the policymakers level. And because of that concern, after 1 year of consultations in UNESCO with governments, the member states of UNESCO decided to approve the UNESCO recommendations on the ethics of AI. That basically it's a document approved by 193 countries, that it's an international framework, an international standard that tries to propose some principles but also actions in areas that have to do with AI, topics like data governance, privacy, gender equality, climate change, impact on the labor market, impact on education. So what the recommendation is trying to do is giving an international standard for government, but also to all the ecosystem related to AI. And there's where I think it could be very useful for you to use it and to see it as a guidance on how to act. It's true that there are several and different ethical codes from companies, from the industry, other international organizations doing so. But what I think it's important, or the added value here of what UNESCO is proposing, is that it's come from an international consensus of governments. It comes with the legitimacy of how we translate those principles that have to do with fairness, with no discrimination, with inclusiveness, into action, into policy. So one of the proposals that the recommendation does is how we consider the ethical discussion during all process. So we have, as I said previously, to consider ethics not when the damage has been done, but since the beginning, how during the research, the development, the revision, until the end of the AI systems, the ethical discussion is always present. And it's present in all actors. So basically in UNESCO at this stage, we are helping governments that are developing AI strategies or AI policies to consider the ethical framework and how they can develop policies and regulations that are based on ethical principles. And to build those policy strategies, it's very important to have a broad conversation with all actors. Of course, policymakers that are worried, but it's important to have practitioners, it's important to have private sector, it's important to have regulators to open the discussion on how we translate really the principles, the ethical principles that we are offering into concrete actions that are reflected in policies. So right now, for example, we are working with Chile that is revising their policy, their AI policy. We are working with Mexico, with Costa Rica that's developing their AI policy, or even Uruguay that it's defining, that has, of course, a strategy, but it's trying to define an AI. And they are also trying to see how this ethics discussion happens. So my last reflection, I want to reinforce the idea that we need to bring together all actors, beginning by you, and here I think that KHIPU and all who participate in this space should be more active in how to participate in these policy discussions that are already happening. You know? So from UNESCO, we are very interested to support you and to open the door and open the discussion, so when the policies and the regulation comes, of course, consider all the perspectives that are happening from the different actors involved. Thank you.
So this implies another homework, which is reading the recommendation. It's long, but I don't know if you have any infographics for that. See? You can begin with, it's not that you're gonna stay at the infographics, but it's a good way to start and begin getting involved in that. Maybe you don't have to attend all the UNESCO meetings. I know they have been lengthy, very long, because it's not easy to obtain consensus from almost 200 countries, but they did obtain that consensus. So, and that's something I thought I would never see in my life. I think it's nice to be involved in the conversation, and sometimes your expertise will be required, and probably you are the ones who are able to provide. So but this is still very abstract, and sometimes we need something more concrete to go on in our everyday life. So our last intervention for this first round is Laura Sion, who is a researcher at CONICET and Universidad de Buenos Aires, and she has over 20 years of experience working in biostatistics applied to clinical research, which means that she has been working with responsible use of sensitive data for a very long time. She's also an adjunct associate researcher at the University of Iowa and holds a PhD in biostatistics by the University of Iowa. For people who care about those credentials. She leads the multidisciplinary data science and artificial intelligence co-laboratory at the Instituto de Cálculo at the University of Buenos Aires. and has been working lately with responsible use of electronic health records in artificial intelligence with some people who are in this stage. She also trains scientists and technicians in these practices that she believes must be contextualized to Latin America, which is why she co-founded and co-directs Metadocencia, with an organization, a non-profit organization that works to make the production, communication, and application of scientific and technical knowledge equitable globally. So tell us about how to. How to.
In 10 minutes?
In 10 minutes, yes, 10 minutes.
Of course. Thank you, Laura, for gathering the four of us.
No, that was KHIPU. Thank you, KHIPU, for gathering these great people here,
well,
and for giving so much room for this topic and relevance, not only room, but relevance.
For leading us in this conversation and organizing us, because you're making it very easy, for me at least, to be the last. And thank you, the three of you, for paving the way. This is going to be very easy for me, or not. But and thank you, KHIPU organizers. You're doing a great job. Thank you so much. I know how much effort this is. And with that, my objective, one of my goals in life is that policymakers like Andres don't feel intimidated in this kind of stage. And I would like all of us to help Andres. And I think we can do it. Okay, but so that's a very general thing. So there's been a lot of different things. I agree with you. Ethical frameworks are not enough, are too general, too abstract. We all agree on the general principles of this. And I came to AI and data science from health sciences and biostatistics, as you heard Laura say. So I've been the only statistician, the only data person in the room sitting with health science professionals for very long. And I've been talking, I've been for many, many years, the one that I had to explain the things like Andres was saying, policymakers don't understand this. Well, we are each experts in our own domains. It would be very unfair to ask all other professions to understand each other. So I think that for a concrete thing, we all need to be very patient with each other. And AI, in the last 10 years, stopped being an equation in a board, and it's becoming an application of everyday life. Right? So, and that's great. This spring is happening, and no one wants to shut it down. But with grayness, and I'm about to quote Spider-Man. Sorry, you were a lot more serious than I, Paula. So, but, with grayness comes, a lot of. Right? I'm talking to. We have a huge responsibility, and we are at the first row. Like, we are all technical folks at the first row. Responsibility is literally at the tips of our fingers every day when we type a line of code, when we receive a bunch of data, right? And in statistics, for decades, and I know statistics, it's not fashionable anymore. So say data science, database, AI. Do you like that term? Okay, let's speak in that term. But it's rather new, so the vocabulary has been changing very, very long. It changes very fast. It goes very fast, right? You've said it. I just don't remember. You said so many things I couldn't retain them all. But I'm not saying anything you haven't heard in the past few minutes and in the past few days. And we are overwhelmed because we cannot follow up with the rhythm. Right? If we are overwhelmed, what do you think is happening outside these doors? So, with the techniques, we are overwhelmed. It goes very fast. So, maybe we need to start asking. And I loved Sarah's talk yesterday, and she was awesome. And but she was saying, you know, well, data is not labeled enough, and I remember an old adage. I think it's still true that if garbage in, garbage out, right? And it's still a thing. I think that didn't change. If you put into your model garbage, I have folks yawning in the audience, so I better do this better. And so if you put garbage, I mean, if the data we have is not good enough, maybe we shouldn't put it in anything and produce nothing that's going to be out there in the world affecting people's life, right? So because a lot of the applications we are putting out there are really changing things very fast, a lot faster that we can regulate, right? So I think regulations, yeah, we need regulations. Sebastián Nunchitel yesterday was asking Sarah, what do you think about regulations, right? I mean, we all want regulations. It must be regulated. But it's taking a long time because consensual society takes time to get to agreements. And that's good, because then we get good agreements. But as Luciana Ferrer was saying when she was opening here, we don't need to, AI field doesn't need to reinvent the wheel on that. That's the good news. Because there's been, like, medicine had to learn the hard way after World War II with human experimentation. And after that, human experimentation was highly regulated. And we had the research review boards for humans, and then all other disciplines follow, like education, and you know it now, NeurIPS, it's having an ethics committee that's very good. So AI is catching up, but you folks, I mean, I know it doesn't, I'm not naive, it doesn't translate, but you can learn from decades of knowledge. You and I and everyone, we as a field, can learn from a lot of other disciplines, and we need to learn from them, and we need to sit each other at the same table, and nobody needs to be intimidated in that table. We need to be one more and contribute to that. So I don't know how I'm doing on time here, but and as a simple first step, if anything else, there's I don't know if you've seen it already. So maybe starting there to acknowledge the responsibility we all have. And remember, we are in the room when the design starts. And we can all say, in statistics, we say, hey, who's your data representing? Can we, summarize the data? Who's included? Who's excluded? Who can we generalize this tool to? I mean, that's common knowledge in public health, like 101, like the first class. Every paper has a table 1 describing the data. I mean, it's boring, I know. It's not sexy, but it's helpful. And AI doesn't need to reinvent that or come to the conclusion of that after it goes wrong. So it's easy. It's out there, and it's really, really, well, if you scrub all the web, it's very difficult. And if you don't know the origin of your data, it's very difficult. So maybe we need to rethink where we're getting our data. And also, you may want to know who labels your data, right? And how they label it. Because garbage in, garbage out. No matter how many nice layers you put into your model and how convoluted you do it. And how many more GPUs or how much more carbon footprint you add. So it's not, I don't see it as complicated. Sometimes we need, I mean, you can prevent, and sometimes you need to, I mean, if a COVID vaccine was not working, it was going to be stopped. And I felt very safe about that, right? And if a food is poisoning someone and it's in the newspaper, you get to know about it, and it's out of the market immediately, right? That's common in Latin America and beyond, but let's talk about Latin America today. So when a government says that it's going to use an algorithm to predict pregnancies in teenagers, I get scared because in a few more years, my kid's going to be teenagers. And I know that's not regulated. So if you don't do it for the rest of humanity, just do it for you and for your families. So that's what I had to say.
Thank you. Thank you. So now you have your third item for homework, which is to read the declaration, see if you agree with that, maybe discuss it, and if you want to sign it, you can sign it. Take a look at it. But we have no action item from Paola. Maybe you can give us homework as well.
I can give you a list.
Okay. Okay, so now let's start our second round of interventions.
Second round of interventions. I really would like to react to all of you, to all of your comments, because I think it's super interesting. Yes, with great power comes great responsibility. I agree. But when speaking about harm, I think one of the problems is that we cannot fully understand what harm can be when we are deploying machine learning technology systems like in the wild. And this is because, for example, you are designing your models and you don't know where these models will end. I was, for example, this case of Colombia, where a judge was using ChatGPT to write his sentence against the rights of an autist infant. And of course, we don't have regulation. But we don't have regulation mainly because there is a lot of money invested by corporations to avoid regulation, to avoid real regulation. So I was, a couple of weeks ago, I was at an event in Mexico. And in that event, organized by the Foreign Ministry, there were many companies, but there were not people from civil society. There were not people like coming from the communities that are affected by machine learning or AI. So in that dialogue, I think we need to include people that are being harmed, because they have to say what kind of harm they are perceiving when these systems are deployed. And going back to Sasha's idea, it's very hard to, of course, compute and to identify what's the cost of training the models, of the impact on energy and water and everything. But there are many communities in Latin America, for example, in Chile, that were opposing to the development of a data center because the data center, Google's data center, was using the water that, was the amount of water that the whole community used for a month. So, of course, they know what are the harms. Everybody knows what are the harms. And regarding ethical recommendations, the problem is that these are not law-abiding because, first, we don't have law, and then we live in a region that we know it's full of corruption and impunity. So our governments, of course, do not pursue like that companies or people in general follows the law. So the responsibility again goes back to the people who are developing, in this case you. But it's hard to trace back the harms. So nobody, again, I was saying that this falls into a void because then nobody's responsible. And one of the things that I've been trying to do over the past few years is trying to test the development of technology in an alternative way. For example, we want to question the idea of inclusiveness and diversity in data sets, because what happens in for example, for a community in Mexico, for an indigenous community in Mexico, that of course is not represented in any data sets because it's a small community. We have 68 languages in Mexico. What happens if someone comes and says, oh, well, yeah, we want to include you in our data set because we need to, our data set to be diverse. But this community is fighting against the government because the government is trying to exterminate indigenous people in many countries in Latin America. Literally to eliminate them from the surface of the earth. So in that case, we don't need to be inclusive. We don't need to leave them safe. We need to keep them safe from, in this case, being a target, an easy target for the government. So these are the things that we would like to challenge, these ideas that are part of the narratives that are out there. And we have been supporting development of AI technologies with a feminist, decolonial framework. And we have been questioning things like, how are you going to build your model? Are you including those communities and people who are supposed to be the users of your models? Have you been talking, do you know the realities of these people? Have you asked them if they want this technology, if this technology is useful for them? So we don't want to be part of this wave of let's automate everything. There was a philosopher called Stigler. He spoke about the automation of existence. And that's what we are living now. Our existences are being automated. Everything is automated. Our thinking, our feelings, our relationships, the things that we do. And we don't want that because, again, our governments, for example, do not understand that there are things that are not possible to automate. And when they are just going to reinforce this idea of the poor being poorer and the rich being richer and women being, women paying the cost of, in this case, technological development. Laura was mentioning the case of this software sold by Microsoft to governments of Argentina and Brazil and other governments to surveil teenagers, women teenagers, because they are presupposing that these teenagers are going to be pregnant. And of course, this is a risk for society. And there were other governments, for example, the Chilean government was also using this software to predict if a teenager was going to commit a crime in the following 2 years. And again, it's the same logic. We are going to automate social control. And these technologies that do not belong to us, these are technologies from corporations, these technologies are being sold to our governments, and our governments are buying these narratives of efficiency and automation and optimization that are undermining our democracies and our human rights. So that's my concern. So I think we can build different technologies. We can build technologies differently, thinking about our societies, the role that we have to play in this geopolitical context, because we are, for them, we are a very good market. Latin America is a great market for these technologies. So what should we do about that? Because we are losing our rights. We are losing our capacity to decide our future. And that's the problem. We are automating our lives, but we are doing that. We are also losing the opportunity to live a dignified life. And that's the task.
So I don't know that can be translated into an action item for homework, but When I first landed into this all these new concepts, something that was very useful for me and that I think kind of starts to go into these territories that you are showing was that we shouldn't think about principles in terms of how they accommodate to technologies, but how technologies respect human rights. So human rights in the focus, not technologies in the focus. And that helped a lot for me, who I am a simplistic person, try to get things done. And that helped because I did not have to look into the complexities of the technology, but okay, is this respecting the laws that are already present in the country or not? And that was easier. Does it discriminate? Does it violate privacy? Does it respect intellectual property? That was simple for me. So maybe, I don't know at what stage of maturity you are into this, but for a newbie, it was very useful. And I'm sorry for interrupting you, but go on with your reactions.
Yes, so I've been trying to do my homework too, and I wrote down some quotes from the other speakers that really, I think, are key things. So Paola said that AI is a technology of privilege, racialization, gender classification. That really stuck with me. Andres said that we need to build bridges between research and policy, and Laura said that responsibility is in our fingertips when we type a line of code. Quote it. And I was thinking, while you were all talking, how that, like what that means for us, for example, for the people who write the code, and what we could concretely do in order to help all these things, to not help racialization, to do the opposite of helping, but essentially to try to connect all these things, right? And I was thinking that, for example, as practitioners, we spoke about values, Laura mentioned values, and so we do choose to a certain extent what we promote as a community. And we don't have to go along with what is in or hyped or in a given in fashion. So for example, ChatGPT, it just keeps coming up. I hate talking about it so much. But I think it's up to us to speak up and say, hey, like we don't know what this model is. Like I said recently, it could be 3 raccoons in a trench coat. We wouldn't know. We don't know. We don't know how many parameters it has. We don't know the training data. We don't know who labeled it, right? Apparently it was crowdsourced and with poorly paid people. We don't know what the ramifications of that was. We can speak up against that. That's part of us as a community. We can say like, hey, I'm not okay with that, and I don't think we should promote that. I truly don't think this is the kind of model we should be saying, hey, yeah, this is a cool model. And I think that policymakers or civil society members can respond to that, because it's hard to read a research paper. It's hard to go through the appendices and understand. But when researchers start talking about it in a kind of a more accessible way, for example, the best paper awards that we give at conferences, that's a very strong signal for a lot of people outside the community saying, hey, this paper was rewarded, it got a gold star, right? And if we give gold stars to papers that, for example, don't share their source code or don't provide documentation for their data, that's also a signal. And maybe it's a subtle distinction, but I think that's important. This is something that we can do. We could also, start ourselves. This is something that, is quite easy. Reporting, training time, energy, usage, carbon, dollars spent, and start making it. There's a top-down approach. Like for example, what we're doing on the NeurIPS Code of Ethics Committee, we're trying to figure out like what we can ask of people, what we can demand of people, right? Like what is something that everyone can do. But there's also the bottom-up approach. Like this is not mandatory, but I'm going to do it anyway, right? Like some of my papers have 10-page appendices, like, if we contacted any other external people, the email that we sent, the way we collected the data, the way we annotated the data, and maybe no one reads these appendices, and that's okay, but, we go above and beyond just because we think it's the right thing to do. This is how science should be, like, these are all the metadata of all the documents used for training our model, and then we have, like, a zip file with literally all the URLs. And so I think that we can start doing something like this. And also when we're comparing models, this is something that, like I've talked to policymakers about. When we say that this model is better than another model, usually we mean accuracy, right? We mean like benchmarking on Glue or Squad or whatever, and we report these numbers, or ImageNet or COCO or whatever you want to use, and that's the number what we use. And then we have these leaderboards with a little curve saying, hey, like papers with code, the curve is going up. But what we fail to compare is the resources that it took to get these percentage points, right? Like, say you have one model that does 95%, but it was trained on one GPU for, I don't know, 2 days, and then you have this other model that has 98%, but it was trained on 2,000 GPUs, and that doesn't figure anywhere on the leaderboards, and that's really, really important. And so I think that like what we start reporting, like not only accuracy, but efficiency, but latency, but energy usage or time, you can start making trade-offs as well. You can start saying, okay, well, you know, I care about accuracy, most people do, but I also care about efficiency, for example. I want a model that will run fast, right? And you can start using these criteria for comparing models, and that's something that's, you know, once again, it's not like a major change. It's not something that will like fundamentally change the way we do AI, but it will actually help people like compare. And also something that I've gone off the deep end on recently is gender and racial classification in AI systems. Like people take it as a given that you can externally you can externally identify someone's ethnicity and their gender based on photographs. And this is something that's like an implicit, like I mean, you know, like we have these labels and we take them as given, and of course some people have started, you know, asking people. There's some data sets that have come out that are more consensual, but you know, most of the data sets like, you know, celeb or A or all these different data sets, they just assume that you see a picture and you can say, yeah, that's a white man. It's super false, and people train models on this, and these models get reused, and we just never even question whether anyone should be assigning labels to people, like, and binary gender is not a thing, right? Like, we have all these assumptions, and so I think that also we can kind of start questioning them. So recently we submitted a paper to FACT, which is like a fairness conference, and we were looking at different text-to-image generation systems like DALL-E and Stable Diffusion, and what people have been doing, even in the short time frame that these systems have existed, it's been like 6 months or 8 months, they've been essentially running pre-trained AI models on them and assigning genders to the images generated by, for example, DALL-E, and saying, okay, well, DALL-E generated 100 men here and 50 women here, and so there's a gender difference. But like, that's wrong on so many levels. These are not real people. You can't assign a gender to a hallucination from an AI model. And so, you know, it took us like 5 times as long to develop like an unsupervised methodology. We tried to cluster the images generated, not saying that these are men and these are women, but these images are similar according to some characteristics like short hair, like glasses, like things like that, and not assigning that these are all the black men and these are all the Asian women. Like, that's what people, and so I think that just by practicing a bit more consciously, like not just saying I'm going to take this model because that's what the previous guy did, but kind of thinking about what that means in terms of like worldview. I think that these are things that we can then transmit to civil society, to policymakers, saying, well, this is the way we want to practice AI, and you know, these are our values as a community.
Mm. This is all being recorded, so don't be worried that you cannot take notes. Andres is going next.
So I just wanted to do some final remarks on this discussion about regulation, that it seems that it puts a lot of tense and it's the intimidation you have when you go back to the policymaker space, the one that I'm having here. But it's part of what we need to work together, and I insist this is a good opportunity. Regulation is happening. AI regulation is already happening. The real question here is how we expect that regulation to be and what we want to protect through that regulation. At this stage, nearly 20 countries are already doing somehow any sort of regulation. So the discussion here is not about if we want or if we don't want. You can agree or disagree, but it's happening. So that discussion is quite complex because on AI, the impact, it's a global impact. So you don't only need national regulations happening because the impact goes beyond your frontier. It's a global issue. That's why it's so important to have global or regional consensus around specific topics. and there's where some documents like the recommendation can be useful. Not sufficient, but useful, because those principles somehow can guide the discussion on what sort of regulation we want. When you talk with any regulator on any country, he always has to do three things. One, understand and have some knowledge on the problem. Secondly, understand what are the interests of the stakeholders. And thirdly, understand what he wants to protect and what he wants to promote. And that happens on AI or in any other thing you want to regulate at the policy level. And those questions are quite important at this moment, because it's not the same that you want to regulate AI to protect human rights or to protect the environment or protect and promote gender equality. It's not the same that to promote AI for surveillance, for economic growth, etc., that not necessarily have to be separated. It can go together. But to be honest, my real concern here is that if regulation is happening, that at the end of the day we have anti-democratic regulations. That means regulations that doesn't care about the impact on human rights, the impact on gender, the impact on society, that it's not able to understand that AI is very important for common good. So at this stage, we are in a very important moment where AI is going very fast, and policy making is also trying to catch up and regulate. And there's where I feel, and I encourage you very much to be very open and participate in those discussions, because you are going to feed how this regulation should look like.
Thank you.
Thank you again, the three of you. And Laura, you are joining all us together very nicely. And again, I didn't note it who said what, but someone said when we researchers, AI researchers talk, the rest of the fields listen, because it's the hottest field right now. ChatGPT is everywhere. And the rest of the fields think they cannot really understand what's going on. So they listen to us. So we need to talk. And we need to make the extra effort of explain in terms that everyone understands. The first step before that's why some of us put together this. And it's very important that if you think what's there in that declaration resonates with you, it's very important, because if folks that know these things align and say, all of this is very important, hey, wait a minute, we can do harm, we need to think about employment, because some of these technologies are already being deployed in the wild, affecting people's lives without the regulations yet. It's coming. Great. The sooner the better, but still coming. And people are being harmed now. So in the meantime, while everything is regulated, we need to do something. And this is the first step, and we are hoping that if the technical community joins forces, then we can speak faster to policymakers, make it easier, and maybe stop experiments to run experiments in the wild. Because biology and medicine, and I cannot think of any other field of human knowledge that runs experiments in the wild unregulated. So that could harm people. So that's not good news for our field. So maybe if we start talking, maybe we can say, hey, maybe we should keep this in the lab. Let's keep experimenting until we understand the harms that are so difficult to understand, though, better. And you brought in the words civil society and general public, and definitely, and this is why I love IRBs. And well, I don't really. I mean, we need. I think every time we researchers do something, we need to start. The first question is, should we actually do this? Is this a good idea? Should we? I mean, should we start? Is this? Whom I may affect, and maybe we have a huge conflict of interest, intellectual conflict. Not just. I'm not talking about money here. I'm talking about intellectual. I mean, I have this great idea. It's awesome. I'm going to change humanity. Awesome. Okay. So that's why it's a good thing that researchers outside of you, that you are not related to, the research ethics board, that have technicians and AI experts, but also, the general public is seated there, and they could speak from that perspective. There's lawyers, there's civil society. Everyone is at that table and say, this is a great idea, go ahead. Or, oh, have you considered this detail that you're excluding, or you might be exposing someone to extermination? And so you have outsiders. And so there's a lot of other research areas that have it. It's normal. So AI doesn't have to reinvent the wheel. And you brought up HIPU, I think, and Jorge Sanchez, he also was warning about HIPU. We need to, it's very tempting, and I fall for it. So we need to, keep an eye on it. So that's that. Thank you.
Thank you. Okay. So now we should be having lunch in 3 minutes or something like that, but we were already starting late, so I guess we can take some small minutes. They will be around, yeah. But in any case, maybe we can have time for some 2 quick questions. Do we have them? Wow. This is good. Do we have, or we have this? Over there. Okay. Yeah. Yeah, over there. Okay.
Hola. Hi. So Sasha mentioned it briefly, but recently some news came about OpenAI using underpaid laborers to label data, and more specifically sensitive data. So I think this is a problem that doesn't get talked much often. So big tech companies usually use underpaid laborers to label tons of sensitive and harmful data, and they usually don't provide enough psychological help for these people. And this is obviously very dangerous for these workers. So my question is, should we share more awareness on this? And should the industry move beyond humans annotating sensitive data? Is this something that is possible, or is this something that is unavoidable? I think how this problem scales now that big tech companies move towards more data-hungry models. This will continue to grow. I would like to hear your take on this.
I think, yeah. I think there's, of course, yes, I agree with your point. We should be more aware of the human costs of AI in general, like data labeling and the labor that doesn't get mentioned. I think we can move towards consent. There are a couple of interesting data sets, actually. There's one called I want to say it's called Dollar Street, I think. And what they did is, essentially, for example, the image data sets that AI models get trained on are mostly made in the global north. And then the way that, for example, even the objects that are in the data sets don't necessarily represent objects as they are around the world. And so these models that are trained on ImageNet or COCO, they reproduce these. They'll for example, they'll only, recognize, I don't know, a certain type of toothbrush, like electric toothbrushes, and if you show toothbrushes from around the world, they're not going to recognize them. And I mean, there's plenty of examples of this, or like toys and things like that. And so what researchers did is they actually got some funding to go all around the world and to give people money and ask them to photograph objects from their homes, like all over Africa and Latin America. And it was really interesting because, like, you see that there are, I don't know, so many different types of toothbrushes, so many different types of like chairs and tables and all these different, and also people, because, the people in these data sets are also obviously quite not representative. And so, but it was all based on consent. It was like, would you like to invite us into your home? Is this okay for you? It was a very, and then finally this data set exists and it's been used for, the thing is, it's not as big as, COCO and things like that. So, but still it exists and it's growing. And it's growing via consent, and they're getting more funding, and they're getting more regions. So I think that if we start adopting these more, once again, bottom-up data sets, not just like crawling all of the web and then getting Mechanical Turk workers to annotate the data, but more like going out into communities and asking them, is there data you want to share with us? If so, what is the framework? Like, are you okay with us? For example, I know that there are some indigenous communities that don't agree with their data being used in language models, or for profit language models, for example. And so going to these communities and being like, okay, do you have data that you want to share? If so, under what license or in what context, right? And going from the bottom up and creating maybe a lot of smaller data sets instead of a couple of big ones that were collected in a way that's much more consensual and much more kind of democratic.
Yeah. And maybe, I don't know, maybe it could be paid better and help offer to these workers. And it's always very good to have, to know how your data was collected and labeled. So you want the folks in the room and know how that work is being done. I don't think it's a good idea for the field to be, I don't think it's a good practice in the long run, technically. So I don't think it's unavoidable, but I'm far from a CFO, so,
There's a lot of work done by Latin American scholars on this topic, and I suggest reading, for example, Milagros Miceli, Julian Posada, Rafael Groman on the human cost of data labeling. There's also a great documentary called The Cleaners on the human cost of content moderation. And also, one of the projects that we supported did an amazing research with annotators from, not Amazon Turk, it was Toloka, which is similar, and probably you know it. And they found out that the people who worked there were women from Venezuela that were awfully paid. So in Latin America, we are having now this problem with people that are working for these companies getting poorly paid, but they are invisible because they cannot organize. Because if you work for Uber, for example, you know who are your other co-workers, but if you work for Amazon Turk, you never have the opportunity to know who else is working with you. So you cannot organize to claim your rights. So there's amazing work that has been done by some scholars here in Latin America.
Mm-hmm. Yeah. Last question. Yeah, and these are all action items that we can take, no? So how do we visualize more this problem? Little things that we can do. Yeah. Sorry.
Hi. Okay, so I'm going to read something short, what he called AI tools. These tools will help us be more productive, healthier, AI medical advisors for people who can't afford care. So these were the words by Sam Altman 3 weeks ago on Twitter. So I just wanted to let everyone know here that he thinks like that, and ask you, please, if you can share like quick thoughts about this. Thank you.
I think I already like responded on Twitter. I remember quoting that. Yeah, but no, but I mean, I remember that really triggered me because it's like, who are these people? Like, it's like perceiving humanity as like one homogenous mass of probably like white upper middle class males from a certain North America, right? And without completely thinking about the costs, right? It's often not the same people who are paying the costs and getting the benefits, and that's completely disregarded in that kind of vision, because it's like this global, holistic, humanity for good situation that is kind of a very ivory tower fallacy, I would say.
And I'm a researcher and a biostatistician, data scientist. And I would like to see the data and the paper and on which Sam is basing his tweet and conclusion or whatever publication that was that you're reading from to demonstrate all those benefits that he claims. And I can bring you, if you give me half an hour, about 30 publications that show and quantify the harms that are already being done and folks that are already dead due to the use of these technologies over the years. So show me the data.
No? Okay. 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 So no one, but this that has just happened here, sorry, is very illustrative of some situations that we are found in very often, that we have conflicts in values, yeah, and in our world conception, and it is not easy to act on that. That's why we are relying on regulation, and we hope that conversations about this can help us build our principles in a more concrete way, so that we can have more definite positions in these situations. Like, am I going to talk against Sam Altman? Am I going to talk about my manager, the manager of my manager? Am I going to be rejected for the 10th time because I'm not reporting the metrics that I'm supposed to report? So these are difficult situations for everyday's life. So I hope that conversations can help us go a little bit farther. So go on, it's lunchtime. Sorry, wait. Yeah, wait. Announcement.
A short announcement. Remember that today we are going back at 1:30, not 2 p.m. as always, okay? Because we will finish early today so that we can then go to the Women in AI event. Then we will share some, the buses will leave from Dassler Hotel, but we'll share the details in the afternoon. Yeah, at 6, I think. You say it. Okay. Yeah. At 6, yeah, okay. So see you.
Hello. So welcome everyone to the afternoon session. It is my pleasure to have my PhD advisor here, Rachel Ward, in this university. Is amazing. So Rachel is the Moncrief Distinguished Professor in Computer Engineering and Sciences and a professor of mathematics at UT Austin. She was a visiting research scientist at Facebook AI Research from 2017 to 2018, and she's recognized for her contributions in sparse approximation, stochastic optimization, numerical linear algebra, and others. She received her PhD from Princeton in 2009, and she was a current instructor at NYU from 2009 to 2011. And now she is an amazing professor at UT Austin. So thank you so much for coming to Uruguay, and yes, give you the floor.
Thank you. Thank you. I'm very excited to be here. Gladly accepted the invitation to come. I love Latin America, and thank you, Soledad, and the other people for inviting me. So I'm going to talk about optimization, sort of the nuts and bolts of AI and neural network training. And hopefully this talk, if you get nothing out of it except that the nuts and bolts, if you look closely, they can be beautiful. And there's some rich mathematics there. And hopefully I give you a taste of that and potential of future mathematics and interesting questions yet to be discovered. So optimization is an essential component of modern machine learning and artificial intelligence. So this is just a very simple example. This is a simple supervised learning example where we have training data and a neural network model, say, depth L with some nonlinearity ReLU or whichever your favorite nonlinearity is. And in this setting, but also just in general, it's standard to train a neural network by fitting the parameters in the model, which in this case are L matrices, S1 through SL, and a vector V. But you can design the neural network model. The weights are just the way you designed it. And then at some point, inevitably, we solve a optimization problem by minimizing a loss function. This is just a simple setting with supervised learning where we have a regression, so a least squares loss. Classification could be cross entropy. If it's not supervised, we might minimize, the model at different data points xj that are considered similar instead of using labels. But there's usually a loss function that we try to minimize. And the loss function takes the form usually of an average of n component functions where each component function represents a different training data point. So some considerations for what kind of optimization algorithms we can use in these settings. So first of all, just, a warning or a caveat, or just I should put it there, optimization is just an intermediate step towards the end goal of making good predictions or generalization, which is the weights W star, which we learn by minimizing an objective function, are used to then make predictions for data which is outside of the training set. And this talk is not about that component of learning, the generalization, optimization. So some considerations for the optimization part. It's often okay to not solve the optimization problem exactly, as long as the end goal of making good predictions still works. So I say minimize an objective function, but approximately minimize is usually fine. Maybe finding a good local minimizer is fine. It depends. So we're not, in contrast to maybe more traditional optimization disciplines, it's not that important to find the global minimizer. The dimensions are very large. Each data point can be millions of dimensions, as in like an image with millions of pixels. There are billions of data points in the training set, and there are billions of parameters, where the parameter now I just stack it as one vector, but it really represents, again, all of the weights in the model. So it increases with the depth of the neural network or the width, however you choose to make your model. And so for such high dimensional optimization problems, we currently can only use very simple randomized first order iterative optimization algorithms. But within that simple structure of first order iterative optimization algorithms, there's still lots of room for novel optimization algorithm design. And that's what I want to talk about. So let's just first start with the very basic first order iterative optimization algorithm is gradient descent. First order means the algorithm just can compute the gradient of the function f that we want to minimize, but not higher order information like Hessians, etc. So gradient descent, you just start from an initial guess for the optimal weights, W1, and then successively move from your current guess, WT, to a new guess by moving a certain amount in the direction of the negative gradient of the loss function at the point that you are. This is the negative gradient direction is locally the direction of maximal decrease, given where you are. So that's why I say it's sort of a very simple algorithm until some criterion is met, like that you're not, the loss function isn't changing very much, and you stop. Notice I put the step size in red here, because we're going to focus on step sizes in this talk. Stochastic gradient descent is a randomized approximation, or a randomized algorithm, which is used as a surrogate for gradient descent. Why? Because in machine learning, again, the loss functions we're interested in minimizing are often these averages of many component function form, called finite sum optimization problems. And so computing even a single gradient of the full loss function involves computing little n gradients of every component function. And so when little n is 1 billion or 10 billion, that just becomes expensive, and like too expensive, not worth it. And so what's often a better strategy is to instead just randomly draw a component at each iteration, or more realistically, randomly draw a batch of components from among all of the component loss functions, and then compute just the gradient of the one component loss function, or a batch of them, and realize that this gradient is an unbiased estimator of the full loss gradient, in the sense that in expectation with respect to drawing a component uniformly from 1 to n, an expectation, it's the direction of the full gradient, and then just iterate the same algorithm as gradient descent, except we move in a direction of this, in this random gradient direction at each iteration, corresponding to just the gradient of a single component or batch of components. And so this is a randomized algorithm. If we were to plot like a trajectory of stochastic gradient descent, we're not going to smoothly move towards a stationary point, but it's going to bounce around, and different trajectories will look a little different. And as we increase the mini batch size, or the number of components that we draw at each iteration, the variance reduces. So, you know, the variance one would see would go down with the mini batch size. Okay, so the point is that stochastic gradient descent, the convergence will be slower than gradient descent, but there's a trade-off. And it turns out that in these modern machine learning algorithms with these large dimensions, it's worth it to increase the variance by just computing mini batch gradients instead of full gradients, especially because, again, as I said before, the ultimate goal isn't often to find the exact global minimizer. A good enough point is often good enough. So our focus is on choosing the step sizes. So I want to start with how one chooses a step size in gradient descent, not the stochastic gradient descent. So for gradient descent, the story is sort of clear. If we consider just a one-dimensional loss function, f, just a quadratic function, this is the story. If you choose the step size too large, then gradient descent can oscillate forever or even diverge. And if you choose a step size too small, then you will make progress towards a good point, but you will move more slowly than we would like to. Okay, this story actually extends to stochastic gradient descent. So it's a story for both gradient and stochastic gradient descent. So what do I mean by too big or too small? So if we start with gradient descent, the picture is really this. The step size being too big just means it's completely dependent on the curvature of the loss function. So if we just think of here, this is a quadratic, the curvature. If we choose the step size too big compared to like the curvature of the bowl, we go off and diverge. Too small, we converge, just not as quickly as we want. And so this is all established, very core theory to optimization of gradient descent. A gradient descent with fixed step size, the convergence of it depends completely on the smoothness constant of the loss function that we're minimizing. So the smoothness constant, one can define like this, that the norm of the difference of the gradient of the function at any 2 points w and z in the domain can be at most L times the L2 norm difference between the vectors w and z. And one of the assumptions in the standard theory for gradient descent, stochastic gradient descent, is that our loss function is L smooth. Now this is very strong, and we're going to talk about this more later in the talk. It's very strong because it's a very global condition, saying that there's this maximal number L, this maximal curvature everywhere in the entire domain. And like intuitively, you're thinking, well, if there's like a really high curvature part of the landscape off over in this region, but our optimization is over here in this other part of the domain, it really shouldn't matter if we have a large curvature over here. So just keep that in mind as to why this is kind of a crude model, but this basic model says that if we choose a step size and gradient descent smaller than 1 over L, we converge at this 1 over T rate here. Very, very quantitative rate bound. And if we choose a step size too large, even by a factor of 2, larger than the optimal fixed step size 1 over L, we can diverge. Okay, so for gradient descent, that last slide might make it seem like we then have to know what the smoothness constant L is in advance in order to set a good step size, in order to get a good optimization. But that's not really true, because in practice, when implementing gradient descent, there are very well-established, theoretically and practically, adaptive methods for just at each iteration of gradient descent, figuring out with binary search, essentially, incurring just like a logarithmic extra number of gradient evaluations, not a big deal, to find sort of the largest step size we can use to approximate the steepest descent, sort of, which would be like the optimal amount of descent. So I'm not going to go too much into this, but it's backtracking line search. You can read more in the book by Nosedal and Wright. And this is implemented in practice. If you want to use gradient descent, line search, and other methods work very well. But when we go to stochastic gradient descent, we're not moving in exact gradient directions every iteration. We're moving in these random gradient directions where each one is just an expectation in the direction of the correct gradient. Line search becomes more complicated, and it's not actually the method of choice in practice for implementing stochastic gradient descent, because you don't want to overfit an adaptive step size choice to a noisy direction. You actually want to take into account statistics of past gradient information that you've seen along the way of the algorithm because of the noise. You can intuitively think of that as wanting to use the statistics to sort of estimate the noise level and use like law of large numbers or central limit theorem to help you determine a good step size at each iteration. So what do we do for stochastic gradient descent? So this is a general form of stochastic gradient descent that includes what I wrote before, where we move in the direction of the gradient of a component function in a finite sum optimization problem. But I can abstract that to a more general form of stochastic gradient descent, which goes beyond functions which are finite sum optimization problems, just to, in general, a form where we initialize a guess W1, and then at each iteration, flip a coin, say. It doesn't have to be a binary coin, but draw a random variable, psi t, compute a stochastic vector, which is a function of xit and wt, the current guess, such that in expectation, the stochastic vector gt is in the direction of the gradient of the loss at the, okay? And then choose a step size, somehow, choose a step size, eta t, and then move, update your weights by moving eta t times in the direction of gt. Okay, and so some standard assumptions, of course, gt is a stochastic vector that is in the direction of the full gradient in expectation. We also have a noise assumption. We're going to assume that the variance of this stochastic vector is bounded. Okay, so this is what I'm going to refer to as the stochastic variance level, sigma squared. And we still assume this L smoothness assumption that I talked about before. So these are standard assumptions that one uses to analyze stochastic gradient descent convergence. Now, sort of one of the theory for stochastic gradient descent, which can be viewed as a generalization of the convergence rate I gave for gradient descent before. Note that I'm talking about convergence here loosely speaking. This isn't last iterate convergence. This is convergence of the average squared L2 norm of the gradients that we see along the way, which implies something about convergence of the minimal norm out of those first t. So I'm saying convergence a little loosely, and I'm not talking about convergence to minimizers because I'm not assuming convexity. I'm just talking about convergence to a stationary point, loosely. But trust me, this generalizes the fixed step size convergence theory for gradient descent. We have this. If we have stochastic gradient descent, the parameters are the noise level, sigma naught squared, and the smoothness constant L. Then in expectation, the average squared L2 norm of gradients of the first t iterations of stochastic gradient descent has this error bound that consists of two parts. There's a first part and a second part. And if we fix the number of iterations that we want to run in advance and then optimize a step size based on that, do some calculus, then we get this rate, which is a 1 over square root of t convergence rate. And when the noise, the stochastic noise sigma naught goes to 0, we collapse and recover the 1 over t gradient descent convergence rate, because then we're in gradient descent. So stochastic gradient descent does not converge as fast as gradient descent, 1 over square root of t versus 1 over t. Again, there's this trade-off. Slower convergence, but much more efficient usually to implement. And finding a good mini batch size, like to optimize that trade-off of convergence rate and efficiency, is often a work of art that people do. So, akin to the story of gradient descent, then do we need to know both the smoothness constant L and the stochastic noise level in advance? Because this whole calculus that we did to find an optimal step size eta, see how it's a function of the stochastic noise and the smoothness constant. So that's a lot. That's 2 parameters. Why would we know either of those in practice? So how does this help us in practice? Well, it doesn't really help that much. Sorry? Sigma 0, what was it? Sigma 0 is the stochastic noise level. So we assume that, and I didn't tell you about the conditional expectation, but that E xit just means condition on getting to the point of getting to WT, conditioning up to that point. Then at that iteration T, my stochastic vector has this bounded variance bounded by sigma naught. Thanks. Please ask. I know there's lots of variables go around, so please keep asking questions like that. Okay, do we need to know them? Well, in practice, this doesn't really help that much, this in terms of figuring out how to set the step sizes in practice, because we don't know these parameters in advance. And so there's a lot of hand tuning, a lot of hyperparameter tuning, step size, pre-tuning by hand, looking for good sort of step-size schedules that just empirically show best convergence rate or best generalization error. And of course, we would like something more principled, something more rigorous than that. Something that people started to use that just seemed to work better for giving faster and more reliably robust convergence of stochastic gradient descent was to use a little add-on. Okay. So there are these adaptive algorithms called, one of them is Adigrad, which we'll focus on, because it's kind of the simplest one. And I'll get back to which one is more popular later. But Adigrad was sort of introduced for a different reason than setting a step size, but people started using it for non-convex optimization and stochastic gradient descent. It worked really well for stabilizing the behavior, the convergence rate. And what the adaptive step size update in the simplest case of Adigrad, where there's just one single parameter update is that the step size eta t in stochastic gradient descent is chosen as for a fixed, think of a small number b naught, could be like 10 to the minus 6, don't really worry about it. But for a small b naught, one just sets the step size eta t to be 1 over the root mean square of the stochastic gradient norms observed from the first iteration up to the current iteration. So root mean square. So note that this step size is completely a function of the particular run of the algorithm of stochastic gradient descent that we're using. And one just sets a small b naught in advance. So it's very low parameter, almost parameter free. And this seemed to work for giving good convergence in practice, and people didn't understand really why in a rigorous way. And so that's what we wanted to figure out. And so this is just Adigrad. I'm just putting it back in the same stochastic gradient descent setting as before. Now, instead of just saying pick a step size, I'm just writing this is one way to just rewrite the Adigrad step size update, so you see that it's not very computationally expensive. We just update some parameter b by adding the norm squared of the stochastic gradient at that time. So we just update this running sum of squares and set a step size and run stochastic gradient descent. Now, if you can see this is a really simple illustration, sort of what's going on in the gradient descent setting. So no stochastic noise. The algorithm still makes sense. And what's happening is this is just a simple linear least squares loss function. And if we just run full gradient descent and we do this step size update, we see in the green and the blue and the orange are sort of fixed step size decay rates for gradient descent, 1 over square root t, fixed step size, or 1 over square root of t. The black is an Adigrad update. So on the left is showing how the convergence rate using Adigrad is much faster. And then on the right, you see the Adigrad, this is the step size, the eta t as a function of t. And you see it has like a two-phase behavior, this step size update, where it starts off decreasing at like a 1 over square root of t rate until it hits like a good level, and then it flattens out and is straight. And that's what happens when there's no stochastic noise. What it's doing is it's decreasing until it finds essentially 1 over L, that fixed step size for gradient descent that's good. It actually goes above 1 over L. It finds like a local smoothness, 1 over L local, and it just stops there. And then for stochastic gradient descent, what would happen is we'd still have a two-phase behavior where it decrease and then level off at a 1 over square root of t rate. So it's interesting. It's like, it's more complex than just a fixed step size schedule. But anyway, so we got some convergence rates, and what we could show is that under these same sort of assumptions that I used before for plain stochastic gradient descent, an unbiased stochastic vector, or stochastic vector which conditioned on all of the iterations up until time t. The stochastic vector is an expectation, the direction of the full gradient, bounded stochastic noise with this sigma naught squared Lipschitz function. We could show, this was a paper with my student Xiaojia Wu, and then later some students and faculty at UT led by Matthew Fa improved this. They said that with this step size update, we can sort of match the same convergence rate of stochastic gradient descent, but without having to optimize the step size. We can match the convergence rate as if an oracle told us L and sigma naught, and we got that really perfect step size. But we don't. But Adagrad can get the same convergence rate up to some constants without doing any fine-tuning of hyperparameters. And you can see what's sort of interesting is this one parameter B naught. You can see that if you just set that B naught in Adagrad to just be very small, we only mildly suffer by having a log of 1 over B naught. So log of something big is not that bad. It's definitely not as bad as something big. So up to an extra log factor, we can sort of match stochastic gradient descent. And this is very similar to the backtracking line search for gradient descent. It has a similar type of result. It requires a logarithmic additional number of gradient evaluations at each step. Yes?
Do you mind going back to the last slide?
Sure.
Yeah. So if I'm understanding correctly, does this essentially require the square of the norm of GT to go to 0 for that flattening out to happen?
That one, yes. That's for gradient descent, no stochastic.
I see.
The illustration there, GT goes to 0. But the algorithm does not require the norm of GT to go to 0. But if it doesn't go to 0, then you'll see a 1 over root T eventual decay. Yeah, so it can adapt to if there's noise or not. Are there any other questions? Okay. And so this is just numerics for a very simple look at the top row. The top row just sort of is a numerical illustration of the robustness of this adaptive gradient algorithm to the choice of step size parameter. It's a little bit confusing, but just the top row is how robust the convergence is to that choice of the one parameter B naught in the algorithm. Whereas if we consider B naught as a fixed step size for stochastic gradient descent, or as a constant in a 1 over square root of T step size for stochastic gradient descent, that would be the blue and the black, you can really see that stochastic gradient descent only has its moment or its good behavior, in a very specific hyperparameter range. Otherwise, it's not very good, whereas the adaptive gradient methods are more robust to the hyperparameters. And the second row shows that we don't really, that even though the theory is just for optimization, we don't hurt the generalization or the learning ability of the resulting weights by using adaptivity. And so that's the second row, we don't really understand why. But these sort of norm single step size adaptive gradient updates seem to find local minimizers or that generalize just as well as if we don't use adaptivity. So that's one question. Okay, I think I'm running a little short on time. So if you're interested in the math, you can look at our paper. But I just want to point out one thing, which is you might wonder, why are we using the sum of squared norms of stochastic gradients? That seems kind of arbitrary. I could use any norm. Like, why that in particular? It came out for us from the theory, which is if we use the L smoothness to do a standard Taylor series expansion to start the analysis, which is what people usually do, there's a term which is basically a sum of random variables that looks like this, AK over sum from T equals 1 to K of AT sum, and then an algebraic inequality bounds this by the log, and that's really where we get this additional log factor, and we get that only with these sum of L2 norm squareds. So it's cute little math. And the other challenge is The analysis of these adaptive gradient methods is more challenging because the step sizes are random variables that depend on the stochastic vectors. So we have to treat correlated random variables, and we have to use tricks like creating surrogate step sizes just for the analysis that are conditionally independent, and then at the end go back to the step size. So there's some really cool math here behind understanding these adaptive methods. Some extensions. The same algorithm can extend to beyond bounded variance noise to affine noise, which is a more realistic noise model, where the noise level is not bounded, but it increases according to the norm squared of the gradient. We can get faster convergence rate in case the loss function is strongly convex and is a sum of convex objectives. So without changing the algorithm, we can get faster convergence under convexity assumptions. And then in nice settings which are essentially satisfied by over-parameterized neural networks in the neural tangent kernel regime, one can show that an even simpler adaptive step size update, where we just update by adding the loss function instead of the norm of the gradient, so it's even cheaper to compute, that works fine too, sometimes even better. And I want to just touch on the most recent developments that I think are interesting in this line of work, which is beyond L smoothness. As I hinted before, this assuming a global bound on the curvature of the loss function globally is very artificial. And you would like to just have an analysis that only cares about the smoothness of the landscape that the actual iterations are visiting along a certain optimization trajectory. And so a recent paper did a lot of experiments on lots of neural network optimization problems and found a sort of similar theme, which is that the L smoothness assumption is too restrictive. The kinds of loss landscapes we see in neural network training are not globally smooth. But instead, it seems that the local smoothness tends to depend linearly on the norm of the gradient of the loss at that point. So this is just a plot from this paper by Zhang et al. Showing, and they see a similar plot across lots of different architectures and optimization objectives. And if you think about it, you can write the matrix factorization problem A minus xy, where x and y are matrices that are variables and construct your gradients, and see that you get this sort of smoothness that grows with the gradient. And so what they showed was they introduced this L0, L1 smoothness model to sort of generalize the classical L smoothness model to explain this sort of phenomenon that they observed in practice. And they showed that an adaptive gradient algorithm called KHIPU stochastic gradient descent can still achieve the order 1 over square root of t convergence rate under this setting. And they did that to explain why adaptive algorithms like KHIPU stochastic gradient descent and ADAGRAD are so popular in practice. And then very recent work showed that stochastic gradient descent with the ADAGRAD update we've been talking about restricted so that the step size is multiplied by a constant factor that's not too large, also achieves this 1 over square root of t convergence rate under these mixed smoothness settings. And what's interesting here, and this is just a conjecture, so if anyone's interested in mathematics of optimization, I think this is a great thing to work on. What's interesting is that it seems very likely and intuitive that one could show that stochastic gradient descent without adaptive step sizes, without adapting the step sizes according to gradient information in the process, is likely not guaranteed to converge in this setting of L0, L1 smoothness. Because why? Because it could, in settings, diverge. If it starts in a bad spot and then the smoothness increases, it could go in the wrong way. So it seems like what's going on is in this setting, this is a setting where adaptive methods converge in a setting where stochastic gradient will not. And so just to conclude, we talked about adaptive step size variants of stochastic gradient descent like ADAGRAD, which we showed they can achieve similar convergence rates to non-adaptive stochastic gradient descent with very carefully fine-tuned step sizes to parameters like smoothness and noise level, which aren't known in practice. So that's very cool. And we conjecture that in this L0, L1 smoothness setting, which is a more general setting than the classic L smoothness setting, adaptive variants of stochastic gradient descent are probably necessary to ensure convergence of stochastic gradient descent for natural classes of functions. And just next steps is that I want to mention that we have this nice theory for ADAGRAD, but in practice, different adaptive gradient methods are usually preferred. In general, it's usually preferred to use an annealed variant of ADAGRAD, where instead of accumulating the sum of squared norms of gradients and then dividing the step size by that the step size can decay too quickly when you do that. What works better is to take a convex combination of the previous sum of squared gradient norms or the previous step size and then add 1 minus lambda times the current L2 norm to that so that the step size doesn't decrease as fast. In fact, the clipped stochastic gradient descent algorithm I mentioned is a special case of this where lambda equals 0, more or less. It's more or less a special case of this. Another special case of this would be, well, not really, but Atom, which is probably the most popular and has a lot of stamina. Atom just keeps working better than other. It's like very, very impressive. Atom combines an annealed version of ADAGRAD here with a very special choice of lambda, but it also incorporates carefully momentum, which we're not talking about in this talk. So there's an ultimate goal in the optimization of large-scale neural networks to understand Atom. That's like, I think, one of the most important open questions. And the adaptive step size, which is actually coordinate updates rather than one update, but that's a part of it. The other part is understanding how that sort of reinforcing that with momentum really, really leads to better convergence. A complication, I say, is that for these annealed versions, it's possible to construct examples where with annealing, we don't converge. We lead to cycles. So we have to really be careful about what is the class of optimization problems we're talking about. And then even on top of all of these adaptive methods, in practice, one often still finds that one can converge faster and generalize better by periodically dropping the step size during training. So somehow there's still more to be said than just all of this. So thank you very much. That's all.
Thanks, Rachel. We have time for a few questions, so yeah.
Thank you for such a comprehensive description of how these optimization steps work. Hi, I'm here, third row. I'm very curious about your intuition about this linear rate scheduling that we often see in large language models, where, for instance, they have this triangular scheduling where they increase the size of the linear rate first, and then they decrease it. There's some intuition about superconvergence and so on. I didn't see that in your slide, so I would like to know what is your intuition about why it's behaving like that, and why we need a linear rate scheduling for those processes.
I think, are you talking about increasing the learning rate at first and then decreasing it?
Kind of a warming up step first.
Yeah. I had intuition about this at some point and then I lost it. Of course, that's also a very important story. Part of the story of the step sizes is that often warming up by first increasing the learning rate and then decreasing seems to do better. Probably someone else has some better intuition about it than I do, but it's not in my head right now. I'm sorry.
Sure. Thanks.
So does your algorithm provide an upper bound on the L constant as a result of seeing where it flattens?
Yes, yes. So in the case of gradient descent, where the g of t is just the full gradient, then the Adagrad algorithm will converge. The step size, 1 over bt, will converge to a constant that is greater than 1 over L.
Great, okay.
Yeah. We conjecture it's sort of like 1 over the local smoothness constant, sort of, right? But don't know how to make that precise right now.
Great talk. So you're talking about, and I think a lot of the work in the field is on these adaptive step sizes or learning rates. But clearly the batch size, you briefly mentioned it, saying it's a bit of an art to pick the correct batch size. And intuitively one would think larger batch sizes means less variance, and so that is generally good, a better approximation of gradient descent. But in practice, that doesn't work. You can't just keep on continually increasing batch sizes. There does tend to be a sweet spot for this. And I wonder if there's any work in theoretically finding adaptive batch sizes as opposed to just fixing batch sizes and perhaps keeping the learning rate constant.
That's a good question. I don't know the answer, but I agree that's a good question, and I have asked that question. It should be answered. That'd be great. More adaptivity to reduce more of the art form fine-tuning, hyperparameter tuning, the more that can be turned into like rigorous self-tuning algorithms with guarantees is great. Yes.
Hello. Thank you for the nice overview. I have a question, which is that normally when we train networks with ReLUs or things like this, obviously smoothness breaks, but the loss curves look quite similar, funny enough, than when, at least when we train like ResNets or something like that. Like if I replace the ReLU with a slightly smoother ReLU, it looks sort of similar. Is this that we are missing something from the theoretical understanding, or do you think that there's something very different going on under the hood, or how do you reconcile this kind of phenomenon?
These are really hard questions. I didn't prepare for these. I don't know. I'm sorry.
It's okay.
Thank you so much, Rachel.
A little announcement. So there is a car, a red car, parked on the entrance of the building. If someone is the owner of that car, is here, we have to move it. Red car. What car? Do we know the brand? No. Okay. No red car. Cool.
Yeah, that's what he said. Okay, he's coming. Perfecto. So it is my pleasure to introduce Elena Caselli. She is a computer scientist, graduated from the Federal University of Uberlandia, and a, yeah, and sorry. I hope I'm saying this right. And she's a professor in Sao Carlos, actually, yeah. But before that, she did her studies at the Federal University of Uberlandia and a postgraduate at the University of Sao Paulo. And she also spent some time in Spain, in the University of Alicante. And she has been a full-time lecturer and researcher at the Federal University of Sao Carlos, Brazil, which is a small city in the state of Sao Paulo. And she's involved in projects with the biggest e-commerce company in Brazil, and another one funded by the FAPESP, which is the main support agency in Sao Paulo for research. So thank you very much for being here in Uruguay. And yes, I'll give you the floor.
Okay. Thank you. I will start say thank you for the organizers and the sponsors to bring us here in this amazing meeting. I am also very happy to speak about Brasileiras em PLN today, one day after the International Women's Day. In this day that we started with a wonderful panel of natural language processing, and then we went to ethics and bias and lots of this that I really think that's important and is related with I will talk here. So my talk will be different from the other ones because I will not talk about products or research or methods. I will talk about people, okay? So be patient with me, okay? It will be different. So the agenda here today will be, we will present our group, Brasileiras em PLN, that for short is BPLN. I will talk about our mission, motivation, goals, deliverables. I will talk about a public survey that we carried out in Brazil last month to get the profile of the women working with natural language processing, Brazilian women. And I will also show you some data analysis from some of the girls, the women in our group. Okay? So who we are. Just a brief interruption here. When they invited me to talk here, I think, oh, I will talk about me. No, I choose to talk about us. So it's a collective presentation here, okay? So who we are? Brasileiras em PLN was created in 2020. I give a talk in widening NLP. It's a workshop. I think that most of you already know that. It was online. We were in the first year of the pandemic. So I did a talk there, and a Brazilian woman that lives in Germany asked me, oh, let's create a group of Brazilian women working with natural language processing. Yeah, let's do that. So we started there, and now today we were 141 women. Here I bring some pictures. Not of all these 141 women is here in these pictures. Some of them just want to put picture in our homepage, and we respect that. So we have here our board, me, Elisa, Graça Nunes, that was my former supervisor, Evelyn, Jessica was my master's student, and Isa. So 2 of them is living abroad in Portugal. And these are all other wonderful girls that we worked with. So what is our mission? So Brasileiras em PLN aims to give visibility to the work developed by Brazilian women working natural language processing for Portuguese language, disseminate knowledge to target audiences like us here, and society in general, and encouraging the insertion and permanence of women in this field. We have, I will show you, but we have women from computation, like me, or also from linguistics, okay? But all of them work with a majority of men in their companies or universities. So our motivation, what is it? I could have bring you some numbers, but I like this picture. Our motivation is just to put some, it's not my picture, it's have the source here, okay? What we want is just to hide the insertion, the diversity of the people that work with natural language processing. But I also quote some, take note of some some quotes from my friends today. Luciana said, Latin America is still underrepresented in natural language processing community. Ivan said, we have to improve the interaction between computational and linguistics. And Maria said, incorporate linguistic knowledge in computer science courses. Before deep learning, we used it to be more theoretical. So this is some of the main motivation to do that, to bring different people together and to strengthen different people, I said computational linguistics, okay? And strengthen the women community in this field, okay? So our goals, we have some of them we are still ongoing. Disseminate and translate scientific knowledge in natural language processing and related areas with a focus on Portuguese language, because most of the books and the papers, they are all in English. For example, we are here in Latin America, and we are all speaking English, not in Spanish or Portuguese, okay? Promote and increase the impact of Brazilian women's working in natural language processing, and also create opportunities for professional and scientific engagement of women in natural language processing. We have some deliverables that some of them are okay now, but bring Brasileiras em PLN to social media. We already have a GitHub, a YouTube channel, Twitter, LinkedIn. I will show you in the next slides. And promote the work of Brazilian women in natural language processing, as well as participate and represent the group in related events, like here in KHIPU, okay? We also want to conceive and share accessible materials like books. We are working in a book. Courses, last year I gave a course in one congress of database in Brazil. Blog articles, all of these materials that address theoretical and practical aspects of natural language processing. And also to promote social events such as technical seminars, roundtable discussions, and create opportunities for field partnerships and initiatives. Maintain channels for sharing useful information and opportunities. These are very difficult deliverables to reach in a volunteer work, okay? But we are trying to. So this is our website. It's a Google site. We are working in a more professional site, so like that. But this is Brasileiras em PLN. It's easy to reach in Google, okay? This is our YouTube channel. We had some of our meetings are there. For example, recently we had Aline Pais, that is from Federal University, Fluminense Federal. Fluminense Federal University, that's the right way to say in English, Marisa, okay. That she talked about ChatGPT and some of all the stuff. Now you can watch, this is in Portuguese, okay. We have our GitHub, it's just a draft one now, but with some linguistic resources in Portuguese. We also have LinkedIn and Twitter, okay? But we don't have strength to make all these go perfect every time, okay? So be patient with us, okay? But to come here, I started a public survey, anonymous public survey, to ask which are the women that work with natural language processing, Brazilian women, okay? So we collected data from a public survey. It was open for answers from February 13 to the 1st of March. And we collected 92 answers. So as you can see, not every one of the Brazilian women answered the public survey, and other women that is not part of our group answered it, okay? So we asked for some social demographic questions, and we discovered that we are more or less like this, okay? She is one of the personas of our group. So most of the women that answered the public survey is in this age, 30 to 49, like me, okay? They recognize the gender that was set to them in the born, most of them, but we also have binary and transsexual, transgender, I don't know the word in English. And we are, the majority of us white women, okay? So as you see, we are women, but we are not so diverse as we would like to be, okay? We also asked about the civil state, I don't know the word in English, okay? But we found that half and half, 49% is married or have some companion, partner, and the other part is single one, okay? But most of them without children. And we know that, Tamar is, okay, yeah. We know that it's difficult for us in academia to combine our professional life with children. It's a problem, okay? We also asked about their education, and we see that most of them finished master or graduation, that is the big ones. And 15% finished the PhD or postdoc, and some of them did the MBA. We also found that most of them were born in the southeast of Brazil, southeast of Brazil, São Paulo, the majority. Then we have Rio de Janeiro and Minas Gerais. For example, I was born in São Paulo, and Adriana no, Argentina, sorry. Yeah, but you live in Minas Gerais, okay. But we also, most of them live in Brazil, okay? We have 88% of the Brazilian women that answered our public question living in Brazil. But we also have Argentina, don't know if you, Adriana, no, maybe. Colombia, United States, France, Germany, Portugal, Spain, and South Africa. Okay, we had answers from all of these countries. So we have Brazilian women in all, but in some places in the world. Okay, in Portugal, for example, I know at least 3 girls from the Brasileiras in PLN that live there. Okay, so we also answered in this survey if they were member of the Brasileiras in PLN. And almost 64% of them asked that they are members of Brasileiras in PLN, and for them we asked more specific questions. So we asked, okay, so what how do you think that your knowledge in natural language process would be, I don't know, classified? And then, so we have experts and advanced in a big group, and intermediate, the middle one, and beginners. So we also have to bring younger people to work with us. Okay, this is our conclusion here. We also asked them to choose some features for how they could, I don't know, describe themselves. So studios was the most, the top one, proactive, and resilient. Yeah, they are women, okay? We also asked them to choose, to put a word there, a free word to represent our group. And as you see, community was one of the top N here, community, sisterhood, that we are motivating, support, collaboration, necessary, okay, powerful. Oh, so this is how they see the group that they are part of. And we also did deep analysis for those women that are already in the Brasileiras in PLN. To do that, we took a look at their curriculum vitae in this platform. I don't know if you know that, but it's called Lattes. It's a platform where mainly the academia puts their research papers, their work in projects, their supervisions, and things like that. I used a script in Python. It's called Lucilates to catch some of the informations and generate some graphics here. And we collect 90 CV IDs for this platform, for collecting their CVs. 42 of them are, so 46% linguistics. They came from have a linguistic background, and 53 have a computational background. So our group is more or less well divided here between linguistics and computational. And from Lattes, I took a look of them, and from these 82 women that have a CV Lattes, just not, but 72 of them with publications or some update in their Lattes in this period of from the born of the Brasileiras in PLN till now, okay? So all this analysis is just for this period from 2020 and 2023. Here I put a summary that for me it's quite impressive. These 72 women collaborating in 69 research projects in these 3 last years. They wrote 12 books, 145 articles in journals, 220 papers in conferences. Okay. About supervision, they supervised 19 PhD students, 49 master students. In Brazil, master is still very strong, okay? 53 undergraduate students in scientific initiation, we say like that, like something like that in Portuguese. And 144 projects for they had to do for the final project for their graduate course, okay? So this is a graph of this publication from these 72 women in this period of the last 3 years. As I said, an annual average of 2 articles in journals and 3 articles in conferences. So it's very good, yeah? So in Brazil, we used to use this, I think that's not only in Brazil, but we use this average to rank the postgraduate courses in Brazil. So this is a very good one. I don't know the level of it, but it's a good one. I also tried to see if, the main journals that they publish. And remember that our group is, this investigation, at least this data analysis, at least was half and half for linguistics and the people from computational background. So they published in Revista de Estudos da Linguagem, this is a Brazilian journal. Linguamática is a Portuguese journal that publishes works in Portuguese. Domínio de Linguagem, it's also a linguistic journal in Brazil. And also other journals that are more general, like Future Generation Computer Systems, Artificial Intelligence Review, Sensors, Journal of Information Data Management, other journal from linguistics, and this one that is more broad scope. But as you see, we don't publish in the main journals of natural language processing in the world, okay? So we have a lot of work to do that, to reach there. I also take a look of the conferences, and there are the main conference in Brazil, like STIL for natural language processing. STIL is a Brazilian conference, and for us in Brazil, it's very difficult to go abroad to present a paper. We have to pay the inscription in dollars. Dollars is like 5 times expensive than real now. And we have to go abroad to travel, and we don't have much support to do that. So it's very difficult to send a paper. I will not send a paper that I will not be able to be there to present, okay? Propor is a conference that happens in Brazil, then in Portugal, every 2 years, okay? LREC, that's LREC, that's a big conference. We also publish papers in AI general journals, conferences here. ENIAC is an workshop inside of the Brasis, that is the main conference in artificial intelligence in Brazil, and other conference, general for AI, okay? And we also have intersection with other areas, like database, web media, knowledge discovery, and education, medicine, okay? These are examples of the intersection of natural language processing with other areas, other fields. And I also tried to see the collaboration between us. So this is a graph. Each node is a person. And we have the connections when they published, they had a paper with co-authoring, okay? So just 18% of the papers in journals was between us, and 22% in conferences. Okay, we are a young group, but we can improve a lot this. This is one of our goals. But just to take an example, this is Adriana. You are here, okay? Adriana collaborates with lots of people here. And this is me, okay? And what about the research themes? When I just run a big RAM Jane to see the main words here. And we found Portuguese, of course, because we have this, I don't know if cultural way to do that. We have to put the language that we are working with if the language is not English. Yeah? Because if we don't, oh, I run sentiment analysis. If you don't say for what language, okay, it's English, but I run sentiment analysis for Portuguese, for Spanish, okay? So Portuguese is a very common word here. But we also have sentiment analysis, named entity, machine learning, because some of the papers, this is one was, I run just for the title of the papers. So machine learning, so we have many people that came from artificial intelligence, but just try things with texts. So machine learning applied to something. Question answering, terminological accessibility, analysis of something. There's some BERT or neural words here in some place. Multilingual here, okay? Literature, and data here, okay? Just to have a picture of the main topics. But they are very diverse. Okay. So our final remarks, just in time. I will talk about just a little about one of the main ongoing projects that we have. We are writing a book, writing by 25 of our members, but plus collaborators, okay? It's not necessarily a book written only by women, okay? We are inclusive, no problem. And the idea of this book is a book in Portuguese with examples in Portuguese of problems of natural language processing in Portuguese, okay? So, and it will be free and online for everyone with code and exercises, and it's a lot of work, okay? I thank a lot NACO by the support that they gave to develop part of this book, okay? And we also working in a new version of our website to get off of Google Sites. And we also see with this public survey that we need to improve the diversity inside of our group. We need to bring more Black people, for example, to be with us. Known for more diversity gender to be with us. Of course, always with gender that has something to do with women. But we have lots of flavors now to investigate here. And also to promote social events such as technical seminars and roundtables, because this is the deliverable that we have to work harder here. It's difficult to do all of this stuff with volunteer work, but we are trying to, and this is one that we have to work harder. That's all. Thank you. Obrigada.
Thank you. Do we have questions from the audience? So if there's no questions, then we can have the break, and then the next talk is by Sami Benji after the break. Thanks. Sami, for coming to Uruguay. Let's start the last session in the afternoon. So the first talk is by Sami Bengio. He is currently Senior Director of Artificial Intelligence and Machine Learning at Apple Research. And he needs no introduction, so I'm not going to read the entire bio, just maybe say that he has been the program chair of NeurEPS and iClear, and he has served in the committee for these several international machine learning conferences, and you know them all. So thank you, Sami, for being in Uruguay.
Thank you. Thank you. So thanks for the committee to invite me. It's the first time I come in South America, so it's really nice to be here with all of you. I'm having a good time. I'll try to give a talk that you can remember some of it. I will try to use two of my hands, but it's a difficult task, so I might fail. So I'll tell you some of the research we're doing in our group at Apple. Our group is called Machine Learning Research, and so that hence the title. Oh, that's, you see. And this is not working. I knew it. Okay. Well, okay. One less hands. So in the group that we started about a bit less than 2 years ago when I started at Apple, is trying to focus on long-term research. By long-term, it's still, we're in industry, so by long-term we mean 3 to 5 years. So what we want is to try to, all of us, work on the projects that could be impactful. They may take like 3 to 5 years to solve, but if they were to be solved, they would probably have an impact on multiple products at Apple and also on society in general. Why also on society in general? Because I also believe that the kind of research that we do needs to be shared. So most of what we are working on is published, it's open sourced, and it's also in collaborations with other people and not just our group or not just Apple. We also believe that the kind of research we do in general in AI, not just in our group, will have an impact on society that is very important. And for that, we really need to have a group that is as diverse as possible so that we consider all the different viewpoints that can impact what kind of product AI could land on and how they are going to impact all of you. So these are part of the reasons I started this group. Works. Okay, so what I'll do in the next 42 minutes or so is to tell you 4 short stories. So 4 small problems and projects that our team has been working on. And I'll try to be as high level as possible so that we don't go into too much details, but we can have a flavor of what we do and why we do it. But of course, feel free to interrupt me anytime, as usual, if you have any question. I don't necessarily see you because there's these lights, but shout. So the 4 problems I'm going to describe. So the first one is about self-supervised learning. And you know, self-supervised learning has been very hot in the past few years. It's a good way to train good representations of your data without necessarily having labels, but just looking at the data itself and using ideas that you know will help the model to improve. I'll talk also about pseudo-labeling, which is another kind of way to use data that has no label or less labels, and I'll see how this can be used, for instance, in speech to improve speech recognition. The third project is going to be about large language models, although for the experiment they are not as large as the ones of today, but what we care about is the impact of these models on society and how these models being trained on large quantities of data
coming from internet. They are often very biased in many ways. Needless to say which ways they are. This simple project was to propose some ways to help debiasing the output of these models so that it better reflects what you want rather than what the data is. Finally, I'll talk about a project, an ongoing project about how to learn to reason, and I think this is one of the harder problems that machine learning has today. And I will actually present something that is very simple and yet hard to solve. So, meaning there's plenty of work to do. So let's start. So the first project I'm going to talk about was a paper that was presented last summer at ICML. It's called Position Prediction as an Effective Pre-Training Strategy. And here's the overall idea. So we've heard yesterday and the day before about transformers and how they are everywhere now. You cannot go without using them in most of your projects. And one of the flavor of transformer that people have been using a lot is these masked autoencoder, where you are going to mask some of the input and try to reconstruct it at the output, and that will help you get a better representation of the world. And this works for many cases. On the left, you have BERT. You've heard of it. On the right, you have a version that is more for vision, but the ideas are basically the same. So there's plenty of things you can do with this, the idea of masking. I think Nando talked about a few ideas of what you could mask. Here, what we are going to do is try to mask the position. So if you remember these transformers, because of the way the attention mechanism works, you lose the position of the tokens, because you're going to compute all possible correlation between each possible input. So what people do in general to make sure we keep the position is to actually add a position vector, saying, well, this token is at this position in terms of an embedding that is added. And you learn that embedding, so it's all good. But so position has a very important meaning, and you should use it when you think that the position should matter. What we're going to do in this experiment is actually to remove it and try to reconstruct it. So we're going to remove the position of some of the input patches. So here what you see is a model that was for vision, but you can think of it also for any other type of data. So for vision, what you do usually is that you cut your image into multiple small patches, and you encode each patch with some embedding, and then these are your input tokens. And you normally add a position vector. Here we're going to remove the position vector of part of them, and we're going to try to predict it as the output. So that's basically what this thing is saying. So it's very simple. It's just trying to predict the position of each of the input patches. This is an example of what that means. In this example, we remove the position of 50% of the patches. Those are the ones on the bottom. We kept it on the one on the top. And we're going to try to reconstruct the image, or at least the position of each missing patch in the output. And then here's what it's going to give you. So it's getting most of these position rights. Some of the things that you see that are gray, it's because when we ask the model to predict the position, it could predict the same position for two patches, which also means that some patches will have no position assigned to, so we cannot show you the patch that corresponds to what it was predicted. So that's why some of these things are gray. So it just means it's not working perfectly, but it's working enough that it actually gets what's in the image, and that's good enough to have a good representation, and it's very simple to do. It's actually very efficient, so we tried it on a few tasks. Here what we show is this blue dot is actually showing, so the x-axis shows how long it takes to train these models, and it's very fast. It's actually as fast as a very simple baseline, but it gets to a representation that is almost as good as this bigger model that may take 3 times to train. And you can show that actually you need less memory, less time to get to a good representation that helps you solve the problem. So it's a very simple thing. Predict the position helps you to understand more what's the input. Right. So I'll move on to the next topic, and that's continuous pseudo-labeling in speech recognition. That's a paper that will be presented at iClear next spring. So what is pseudo-labeling? Actually, it's a very general thing that you could use in many tasks. It's been shown to work well in speech, but we also tried it in other tasks. So the idea is the following. Your setup is you have a training set where a small number of examples have labels and a large number of examples don't have labels. So for speech, what are labels? It's you have an input is a sequence of audio, and the label is a sequence of words or tokens. What was said for this particular speech data. And so it's quite tedious to actually label each of these audio snippets, but you can actually record a lot of them without too much work. So how do people use the idea of pseudo-labeling? This is the graph you see on the bottom. You get some amount of labeled data, that's the green thing at the beginning, and you train a first model. And with this model, you are going to actually use it to label more data that didn't have any label. So that's the blue thing that you see here. With the combination of the new labeled data, which is actually not really labeled, it's a pseudo-label, because we don't know whether these labels are true, plus the old data, which is correctly labeled, we have a new training set that we can use to train a new model. That's model 2. And usually this new model is actually better than the first one because it benefits from more data, even though the labels of the new data set is more noisy. And you can continue and do that a second time. You take this new model, model 2, you label more unlabeled data, and you train another model, model 3, and you can go on. But of course, this is very long, tedious. You have to train multiple models, so sometimes you stop before you should probably. So what the continuous pseudo-labeling idea is that actually, first, you're going to train yet a first model with your labeled data, and then you are going to train a new model that is going to be on the spot adding new labeled examples. So as your model improves, you label more examples, pseudo-label more examples, and you use them to train more your data. So it's not separate models, it's still the same model that you keep training. That works well, but the problem here is this reliance on this initial model. How should you train this initial model? Turns out that it's not as simple as it seems. You need to train in enough, but not too much. So it's kind of a dumb thing to be, because then you need to try multiple options and see what happens afterward. So what you see on the graph here is the metric that most people use in speech. It's called the word error rate. You want this to be low. And we tried to train these initial model for a different number of iterations, 40K, 20K, 10K. And as you train, if you train too much, actually, it's going to not work. If you train not enough, it's going to diverge. So the actual solution is not simple. So what are we going to do? We're going to get rid also of this model. So we're not going to start with an initial model. We're going to have only one model that starts with the label that you have and pseudo-label that we get on the fly. This looks weird because your first model is completely random, and with this random model, you're going to label something. Of course, the labels are going to be probably bad. So we need somehow to regularize this. So there are two tricks for this to work. The first one is that these labels that these examples that you pseudo-label, you shouldn't rely too much on them at the beginning. So if you see that the examples get to be labeled differently from iteration to iteration, you should probably get rid of the previous ones. So remove them from the cache that you're using to train your model. And we're going to use like a probability to decide whether we keep them or not, and that probability will depend on how much the label has changed over time. which means that at the beginning, we don't keep too much of the old label, and at the end, we're stable and things are going to work faster. The other thing that we do is this idea of sampling. So these generative models, you probably understood from the other presentations that you can generate more than one sequence of tokens. Most people use, in this field, the argmax, or one sample and just use it as it can. The truth, so for sequences, the problem is much more difficult than for a simple classification task. For a classification task, you get your distribution of which class it could be, and you take the max, or maybe you sample, depending. For speech, it's a sequence of tokens, and of course there is a language behind this, so they are not independent. Each of these tokens depend on each other, and if you are not careful, you're going to get either really bad samples or only always the same. And we want to be a bit in the middle. So we have a process that makes sure that the samples that we're going to get as pseudo-label are going to be diverse, but not completely random neither. But it's actually a very simple hyperparametric set. It doesn't vary from task to task, but it's needed to make smooth labels. If you do all that, it works, everybody's happy. You get to be much better than if you only trained on the label data, and you get to have a much simpler procedure than if you had this multiple set of models plus the first one to train. So simple procedure overall. Good. Let me tell you about the third project. It's called Self-Conditioning Pre-Trained Language Models. So we're going to talk about these GPT-like models. That's these pre-trained language models. And this is a paper that was from last year at ICML. So we heard of all these. There were like tons of talks this week about them. And you understand now that you provide like a prompt, and then you let the model generate something, and you get a sentence. All of that is fine, nothing special. But suppose that for some reason you'd like to make sure that the model is going to be biased in a way that you decide. So here, I would like the model to be biased towards talking about elevator, which is a nonsense, but it's just to illustrate the problem. So we're going to discuss about the process that helps you do that. And if you apply that process, what will be generated will be more about elevator. Now, who cares about elevator? Of course, the real thing that we care about is to try to remove some of the biases that are inherent in these large language models because of the data they were trained on. There are many ways to do it. We are not doing fine-tuning. We are not retraining our model. And it's not about prompting either. It's not about finding the right prompt. It's not about doing the soft prompting where you actually learn the prompting. It's going to be another technique that will give you some opportunity to unbias as much or as little as you want, depending maybe on the context. So here is the overall idea. When you put in a sentence in the model, here Messi kicked the ball, and you observe the unit of the model. So what are the value of all the units in your model? And in particular, the units that are at the output of all the linear layers that you have in your model. You are going to see that some units often trigger for some concept more often than others. And some not only do that, but they are very low when it's not about that concept. So some units somehow encapsulate some concept that might be of interest. Now, you have to find them, of course. So it's not that difficult. You need to gather a small training set, and really it's small, like a few hundred sentences that you know are talking about the concept of interest, and a few hundreds, maybe thousands of sentences that you know are not talking about the concept of interest. And with this, you are just going to run these sentences towards your model and look at all these linear units and see if it actually does what I just said, which is the positive sentences trigger these units high, and the negative sentences triggers these units very low. And you can compute a single number that actually tells you how likely this unit is going to be triggered mostly for this concept. So why do we want to do that? Again, it's because we want to try to find ways to mitigate some of the biases that exist in these large language models. Let's take an example here. If you output the nurse said that, given the state of affair on the internet, there's a high likelihood that the sentence will be about a woman. And so it said that she was eating. But the nurse didn't say whether it was a male or a female, but it's going to be inferred by internet. So can we change that? Can we make sure that maybe 50% of the time the sentence will be about male and 50% of the time it's going to be about female for this particular case and bias? Well, so you can, and once you have identified units of a given concept, you can actually decide to, so the way you use that model is to, when you input the sentence, the nurse, what was it? The nurse said that, you are going to fix some of the units, the ones that you know are about male or female. So for instance, if you want 50% male, you are going to decide on the number of units that you know are about male and switch them on irrespective of their input. So normally the input, the value of a unit in a network is, you know, the weighted combination of the input, of the values of the inputs of that unit. You're going to forget about this number and put instead a number that is high, and you can, there are details about how high it should be. And the only question is how many of these units you should do, and that's a hyperparameter that you can find for each of these concepts. And you can see on the, like, let's look at the top graph on the left. The x-axis is the number of units you have to trigger to change the output of the sentence so that it's more about male or more about female. And there is some variance, but you can see this, that at some point, so you'd like, if you want to be unbiased and have as many male and female related sentences given that concept, you will want to select the number of units that is roughly in the middle, because that's at the point where it crosses the probability of being one or the other. And you can do that for all your concepts, and then, you know, change your model accordingly so that some of the units only trigger the way you want them to trigger, and irrespective of the input. So this is an ongoing work, but this is working quite well. We haven't tried on GPT 3.5 or later versions. How am I going on time? Sorry. All right, plenty of time. Yes. All right, the last topic is about learning to reason. And this is a sequence of papers that started when I was at Google. So some of the co-authors are from Google. And then I moved to Apple, and some of the co-authors are from EPFL in Switzerland. And it's an ongoing research. So let's try to stay at a high level. What do we mean about reasoning? Actually, we're going to start way before that. How machine learning works in general is to make some assumption about the data. So you're assuming that you have access to some data that comes from a distribution that you don't know, but you know that the training set comes from that distribution. And you also assume that the test set comes from that distribution. And if you have this assumption, then you can say a lot of things about whether your model is going to generalize well or not. So this is like at the basics of Machine Learning 101. So this only works for IID. Of course, you all know that real life is not like that, I suppose. Real life is someone gives you some data, you don't know where it comes from, it tells you to train a model, and you're going to use it on, you know, on the web or on some application, and you hope it's the same, but of course it's not going to be the same, and you can just pray. That's real life. And this is what happens when you do that. you get a chair. It is a chair, but it's very far from the chairs you may have seen during training. It's far in many respects, and maybe that's why it's going to fail, but we want to understand what's happening. So let's, the simplest case of generalization is your test data will come from the same distribution as your trained data. And in some cases, it's also the same examples, because that's life. So these examples may happen more than just in the training set. So that's what we call memorization or generalization. All of these things work in the IID case. Sometimes you have what people have started to call out-of-distribution generalization. This is when you have a training set, and in the test set, you're going to see examples that are quite similar to those of the training set, but somehow they have changed in ways that are non-obvious, but still everybody would agree that they are of the same label. So here you had chairs in your training set, and in the test set you have a drawing of a chair, but it looks like a chair. Or you have a chair in an unconventional position. Most people don't see these chairs upside down, but we all recognize the chair anyway, so there's something that we need to learn about that. And then you have this thing, which are other chairs, which the only thing they have in common with other chairs is not their form, but their function. What you do with that, you sit on it. But that's the only thing. So there's something like a higher level reasoning question about what is this and what is this for? It's a chair, I should sit on it. So yes or no. And most likely, if you are training a model on images like the bucket on the left, you're going to get very poor result on the bucket on the right. Now, I'm not going to solve that problem for you today. Don't hope. But I'm going to try to lay out some steps towards that, and very tiny steps still. So these, what I call reasoning tasks, where it's not about just doing a simple pattern matching thing, but doing higher level thinking. They appear in every corner of the world. You have, you're going to have that in arithmetic, in algebra, in visual reasoning, physical reasoning, algorithmic reasoning, and reasoning on graphs. And so these are just examples for which I actually saw references and actually data sets and papers trying to solve these problems, and they are hard. And of course, they're going to solve it a bit, and that's good. But what we are going to do is like 10 times simpler than all of these. Because at the end of the day, what we want is first trying to understand what's going on, and maybe one day we can get to that. Instead of starting from the most difficult thing and just hope for the best. So what we are going to do is design a series of experiments and data set for which we control everything, and we control the difficulty of the task, and in a way, the level to which we need some reasoning to be able to solve it. And we're going to measure and see what's hard, what's not, what are the intrinsic biases of our models, and things like that. So our family of problems, we call them the pointer value retrieval problems. And for now, they come in two flavors, but it's easy to extend that to much more complex setting. But in this setting, you're given an input, and the input can be images or it can be just numbers. And part of the image that you see contains like a pointer that tells you, oh, you should look at this other part of the image. Once you go to this other part of the image, you decode what's there, and you give an output. So there's like two things to do to be able to solve the problem, and you need to learn to do these two things. And of course, you can make these things much more complex by having multiple pointers, a pointer that points to a pointer that points to a pointer that tells you what to do. And you can see how difficult all of that is. And let's see. It looks simple. Let me give you like a simple example of what I meant. Here, you have images that contain 4 different MNIST digits, 6091. And each of them is in a different corner, top left, bottom left, top right, bottom right. So far, so good. The designers we'll know that the pointer is the top left. And that depending on the value of the top left number, we're going to look at a different place. So for instance, if the number on the top left is between 0 and 3, then you should look on the top right, and here it's a 0, and output the 0. If the number of the top left is between 4 and 6, as it is now, because it's a 6, then you should look at the bottom left and output that number, which is the case. We go, we see a 9, and we output the 9. So that's the task. If you don't understand the task, please let me know. But these are the 2 steps, pointer, retrieval. We can also make it even simpler so that we control even more what's going on and remove everything about vision tasks by having only numbers. So the input is going to be like 10 or 11, I think, numbers. The first number is going to be the pointer, and it says where to look at. Here the pointer is 3, and the way you count 3 here is that you do not count the counter and you start at 0. So you count 0, 1, 2, 3, and you get to this position where there's this 2, and that's the output that you're supposed to give. Okay, so that's the task, very simple. Of course, we're going to increase the complexity of these tasks as we go to understand how it affects, quote, quote, reasoning generalization, and we'll see what happens. There are a couple of ways to do that, and I'll describe all of them. Okay, so let's go back to this first example. And in the IID case, every single digit can appear in every of these 4 corners. So 0 to 9 can appear in all these corners. You can train them all on that. And if you test, you're going to get the same distribution, and likely things will go well. But now we're going to play a game, and we're going to hold out some numbers. So for instance, on the top right, during training, we're never going to see values 0, 1, 2, 3. And on the bottom right, we're never going to see 7, 8, 9, etc. during training. And of course, at test, we are going to only see them just so that we understand the contrast between the two. Now, if we had a model that was trying to disentangle, what you see and how you use it, you should easily see that these numbers appear anywhere. And if you learn what is a 6, it shouldn't matter where it is, of course. But if you only see, if you never see 6 on the top right, what will happen when you actually see them? Well, not great. And let's try it indeed. So first graph that we see, the 2 of them are just 2 different models. We train on the task I described, and we test on exactly the same distribution. So it's an IID setting, and yes, that works. So the accuracy, which is the y-axis, goes quickly to a very high number, and so you can see that it actually learned the task. All good. But when we now go to this hold-out shift setting, and we only measure the performance on these numbers that were held out, well, you can see that it's actually completely failing. There's just no way it learns it. And we can look at exactly what happened in the model. So let me guide you to what is happening in the model. Let's go first on the right side, the IID setting. So that's the setting where we know it works because train and test have the same distribution. Let's look at the blue dots is the output of one example. And the input of that example was 0869. And the output is what we see, this logit value. So we have the output for the class 0, 1, 2, 3. That's what you see on the x-axis. And so what we see first, what was the actual target for this 0869 task? Because the pointer was 0, you had to look at the first number, which is an 8. So the task should say 8. And indeed, the score of the logit for the 8th thing is the highest. So all good, it works. On the right side, with a similar example, what happens now is that the model was trained and never had to output anything that was high for the first digit, for instance. So it's going to fail. And like here in the example, it says for the blue example, you should output a 3. That's what this thing says. And all the logits around 3 are all low. Instead, it's going to output something else, so that's why it's failing. Of course, it makes sense because it never saw that number, but if it understood what was the number, the task, the high-level task, was the same, but it didn't see a number at a different place, and so instead it kind of did just a simple pattern recognition process, which is not what we'd like to be. And again, you could solve this task by engineering a model, but that's like beyond that's not what you want. You want the model to be able to find it in a way, or to put the biases in the model so that it's going to find it. So another thing that we can do is making the output function more complex. So here, in this example, you have a pointer, 3, which means you have to go with a 2, this number. But we can make it a bit more difficult by saying, once you arrive at the 2, look at all the numbers around. So that's a window. And with all these numbers, there's a function that aggregates them into one number, and that's the output. So for instance, if the function is mod sum, so it's basically saying sum all the numbers that are around and output the modulo 10 of that so that it's a number that is valid. And if you do this, that the answer is 3. But you can change the function. You can have, majority vote, min, max, whatever. You can invent the function that you like with that, and you can see how hard it becomes and what happens. So these are examples of what happens just for the mod sum, which we found being the most difficult one. What we see here, so on the top, you see curves that are training curves. You want these numbers to be high. It's accuracy. On the bottom, you're going to see test accuracies, so you also want them to be high. Each of the panel have a different number of neighbor. That's the size of the window. So when the window is of size 0, it's only the number that you see. When the neighbor is of size 3, you have to take into account much more number. And finally, we vary the size of the training set, so examples. So what this thing says, basically, is that as the neighborhood grow, it requires much more training set to be able to solve it. And in fact, in some cases with neighbor 3, you're not even able to solve it. So it becomes suddenly much harder. You can play with different aggregation function, and you find that actually one of them is much harder than the others. Let's not go into too much details, but indeed, you need much more example to solve this mod sum task. We wanted to understand why it is so that by growing this neighborhood, the task would be difficult. So there's this notion of noise sensitivity that you can play with, and the idea is the following. So let's take our examples. They are numbers, and we are going to encode them with bits. So each number can be encoded with 4 bits. So at the end, the input is just 40 bits or 44 bits. And that's your input. And now we're going to add noise to this. So we're going to flip the bits randomly according to some number. So delta is the probability that you flip. And we are going to see what happens in the output when you do that. And what you observe is that as the neighborhood function grows, the sensitivity of the function it's bigger. So the task gets bigger. That's what the left curve says. And the right graph says that some of these neighborhood functions are much harder than others. Actually, the mod sum is by far the most difficult one to solve. So at least we have a good understanding of why this is happening. It's really just because of the difficulty of the robustness of that function. And we showed some of it in some recent papers. So the one thing that we think, and we actually showed some of it in the current submission, is that every model has different biases, inductive biases. And some models are going to be more able to solve this task than others with less examples. And that's indeed the case. And in particular, transformer is the model that has the best inductive bias. I'm not saying why, but I'm just observing that indeed it is going to require less examples to solve more complex problems with the same amount of training examples. So, yeah, maybe let's go on to this other task that I think is interesting. It's the held out. You remember the held out when I talked about some, like the top right corner will not be visible in the train set for some cases. So we can play a similar game here. We are going to, so when you take this function, aggregation function, say of size 3, and it's mod sum. Mod sum is a function that does not depend on the order. So 0, 1, 2 is the same as 1, 0, 2. Should give the same thing when you do mod sum. So we can play a game, and during training, we're only going to see some combination of 0, 1, 2, and during test, we're going to look at what happens on these other combination. So that's, if really it encodes mod sum, it shouldn't be changing. It's the same idea again. And indeed, it's only working once you get like millions of examples. So it's unclear that it's not memorizing again. So it is a hard task, and we haven't solved it, and despite this being very simple. So let me conclude, because we're almost at time, and we want to have time for questions. So I've shown you a sample of some of the work that is happening in our team. There's much more than that. For instance, you heard earlier this week work from Marco, who works on optimal transport. We have people working on privacy-preserving machine learning. We have a lot of people working on improving machine learning in many ways. People working on fairness issues, embodied machine learning, and etc. And there's a lot of work to do, and hopefully we'll try to be able to solve these hard problems. One of the things we've been working recently, and we have a submission currently, is this problem of length generalization. So you're given a task, and let's take the parity task. So you're given sequences of binary code, and you have to say whether it's even or odd, the sum. If you get training examples of up to a given size, it's going to be very good of up to that given size, and it's going to start to degrade as soon as the size grows significantly above this. And now we have a good understanding of why this is happening, even for transformer and other models. So there's more work to do, but that's where we are. With this, I'm done.
Thank you very much, Sami. Do we have questions from the audience? Yes?
Where is the mic? Actually, I don't see it.
Okay. Thank you, Sami, for your presentation. So regarding the third one, the self-conditioning, here. The self-conditioning generation with language models, did you try turning off the expert neurons and seeing if you were able to remove certain concepts from the generated text?
Well, what you can do instead is consider the inverse of that concept, and if you have enough examples that describe this is not that concept, you can turn it on if this is a unit that is often on when this is not about that context, and that's going to do what you want.
Okay.
Yes.
Thank you.
Like it's the same idea as male or female, you can choose either side.
Hello, Sami. Thank you for your talk. My question is, does pseudo labeling accumulate bias and error? And if so, how can you deal with it?
Can you repeat?
With pseudo labeling, which was towards the beginning of your
Yes.
presentation.
Yes, yes.
Do you get accumulation of bias and error? And if you do, how do you deal with it?
You do, and you diverge indeed if you are not careful about if you start by sampling a lot of labels from the model when it's not good enough, and you get like a random set of labels, then it's going to diverge, and that's why you are controlling that at the beginning to make sure that your labels are stable, whether they're true or not. At least they are stable. They always say the same thing for the same question. And if they are not stable, you remove them at least temporarily, and later on they might reappear. So that controls for this divergence.
Thanks, Sami.
Okay, so thank you for the talk. My question is actually quite related to what he said. And I was going to ask you a little more, maybe a little more crazy question, which is there any kind of base, like fundamental theory, or is anyone working on conditions for this? I mean, it's fascinating, the pseudo-random, pseudo-labeling process as a kind of dynamic system, any kind of ideas on how to make it like not diverge besides like heuristics? I'm just questioning very.
Yeah, unfortunately, I don't really have, I mean, I have just a high-level understanding, but definitely not any proof. I think I saw a few papers that are trying to explain pseudo-labeling and why it works, but not in the continuous case. So, like, think one example of this pseudo-labeling setting is when you train a teacher model and you use it to train a student model, and it's a very similar mapping, but you only do it once, but still people have studied this setting because it's a much simpler one, and there are good reasons for why it works. There's these ideas having this dark knowledge, which is that instead of having just one label, you actually have a correlation between labels, and you get some information that you wouldn't get from other labels. So that's one line of understanding of what is going on, which we simulate by sampling. So instead of showing the whole, using the full distribution, we sample from it, so we get different sequences every time, but you get the same idea. That doesn't, I don't explain it, but others do.
So you explained this interesting idea that a chair is something you sit on. Do you think that embodiment is very important, or is fundamental for actual reasoning? And do you guys have any ideas of how to make embodied knowledge?
So you mean like grounding?
Yes, yes.
Yeah,
Yes.
Yeah, I think it's going to be fundamental. I think we won't be able to solve like difficult tasks that reason on the real world without some kind of grounding. Yes, but this is only my intuition. Yeah, that's probably related. I think to understand the function of a chair, you need to understand way more about the world than just the pixels that you see. So it is a much harder task, and we need to actually try them. Maybe.
Thank you.
Thank you.
Yes.
Hopefully, did you? So we have the last talk of the the day. Before we have the, after this talk, we'll go to the, we'll go to the Women in AI. So there are going to be buses from the hotel. Huh? Do you wanna?
Also stay because we'll do the photo at the end, and we will give some more announcements, so please stay.
Okay. So, excellent. So we'll welcome the last speaker of the day. Her name is Nayat Sanchez P. She is originally from Cuba, and she is currently working in Chile as the director of the INRIA Research Center, and also she is the CEO of the INRIA Chile Foundation as well. She has a lot of accolades and a very extensive CV with experience also in both research in academia and in industry. And in particular, she was a professor in Rio de Janeiro, as well as a professor in Spain in the University Carlos III of Madrid. And so I'm very happy to have her here to give the last talk of the day on climate change. Thank you.
Thank you. Well, thank you so much, and well, good afternoon, everyone. It's a great responsibility. I mean, talking after Sami Benjo. Thank you, Sami, for warming up the audience. Well, again, it's awesome to be here at KHIPU. I mean, in Montevideo is, I would say, my first time also. Even though we're in Latin America, thank you so much to the organizer for having me. It is really a great opportunity to speak in the context of an event such as KHIPU that have been trying to keep the connection between Latin America, which I think is extremely relevant, especially in an area such as AI. So the focus of my presentation today is an area where I have been working, and we have been working at INRIA, which is AI for Good, and in particular, AI for Climate Good, which is a very relevant topic in the convergence also of the state of the art of artificial intelligence at the moment. This is a work in progress and in collaboration with my team and some colleagues of the project. So first, I want to introduce you our center, because maybe some of you do not know. Well, INRIA is the French National Institute for Digital Sciences and Technologies, and we are big at France. We are 300,000 researchers. We have 9 centers distributed in all along France, and it has 1 center outside continental France, which is in Chile, okay? We are in Chile, and this is a very good question. Everybody asks the same, why Chile? But we are in Chile motivated by the opportunities of Latin America that offers related to diversity, also for biodiversity, but also, and mainly for the talent, for the top-level research and innovation in many domains that we can do with so many collaborators and researchers from Latin America. So this is the main really motivation. And also, India has a research institute for digital sciences and technology, has also been committed to environment for many years. And what I'm going to present today is an example of it. It is part of our research on the convergence of AI, machine learning, and climate change. But the way, if you have used scikit-learn, and here probably most of you have, then you should know that INRIA is behind it. So here's a picture of our building in Santiago. Do not hesitate to visit us. If you come to Chile, we're in the 12th floor in Santiago, and we are in Chile since 10 years now, okay? Well, let's go into the topic. Well, I'm going to discuss right now the impact of AI with respect to climate that can be grouped in these 3 big axes, big areas, I would say. First, it is pretty obvious that AI can accelerate the climate action via applications such as, I mean, we have a lot of examples: forecasting solar power production, optimizing buildings, heating and cooling systems, pinpointing deforestation from satellite imagery, and analyzing corporate financial disclosure for climate relevant information. There's a lot of things that we can do via applications. And here, the importance of AI goes beyond the obvious idea of making things
work in an optimal way, because one of the things that is happening and that the climate change is causing is that a lot of knowledge that we have been accumulating through the millennia, let's think on agriculture, fishing, I don't know, all of the sudden, all of this knowledge is being rendered useless at a very fast pace because climate change is changing, and the conditions in certain parts of the planet are changing dramatically, and it means that to be able to accommodate the productive agriculture and productive and efficient fishing industry, we need to relearn all of that at a very, very fast pace, and we need AI for that. So this is the first thing. The second thing is that AI is essential for understanding the climate phenomena, which is very complex, as you may guess, what we can do to mitigate and hopefully revert it, okay? These are all big questions, very ambitious questions that, I mean, we need to progressively divide, understand, and call for intrinsically interdisciplinary approaches, because this is a very, very complex problem. And third, we have the issue that AI, as you know, is becoming more powerful, and we have bigger models. We have models essentially consume a lot of more energy to be able to run, and consequently, they have big potential impact regarding CO2 emissions, and this is becoming more and more evident as time goes by. So the question is very relevant, and really makes me proud that as community, we are really addressing this topic in such an early stage, because many other sectors like transportation, energy generation, they have just started to look at their ecological footprint only after it was very evident that they pose a real problem like pollution, like ozone layer, etc. Okay? But in contrast, in the machine learning community, I mean, it's one of the first on which important costly results like language models, for example, are shared for others to use. There is a culture of sharing results, and of course, things are getting more complicated. I mean, they have a bigger footprint, and we are addressing this in a way that addressing, I mean, the ecological way of doing AI. And in many aspects, also, that is related somehow with accessibility also of technology. But in any case, we know that NP-hard problems will be always NP-hard, and at some times, they are not avoidable, and in any case, it's something that as professionals we should address, and I know that not only us, but some of you here in the audience are already working on this, so I today will be focusing on the second block, on how we can use AI and machine learning to understand climate change. So if we think on how AI can accelerate climate action via application, there's a very nice paper from colleagues for climatechange.ai. I think there's someone here from climatechange.ai, right? I think in the morning it was. Okay, well, that is a survey of potential application scenarios with respect to the AI ML techniques that can serve for this, okay? They have mapped a lot of areas where different machine learning techniques are applied in different domains, and it have to do with stealing raw data into actionable information, improving predictions, optimizing complex systems, accelerating modeling and discovery, and this is applied to a lot of sectors, electricity systems, energy, transportation, agriculture, but also health, education, collective and individual decision, crisis, social systems, etc., okay? And also in the sense of the machine learning and AI techniques like causal inference, computer vision, reinforcement learning, NLP, and many others that can serve to all of this, okay? This paper is a little bit old now because it's 3 years old in our field. This is a lot, but probably now it's incomplete, but I think there's still a good reference for you to check out, okay? Well, as I was saying, in Chile, in INTREA, we have an important focus on AI for good, and in particular for climate good. And this is not the only topic that we are working with in a transdisciplinary way. We are also working on astronomy, smart agriculture, energy, and many other sectors. But we have a strong emphasis in Chile on how we can use the digital technologies and particular artificial intelligence for good, and in particular for climate good. So we have been working, and we have projects on green and artificial intelligence. I mean, this is consortium, Latin American consortium, Franco-Latin American consortium, okay? I'm very proud that some of you of this consortium are here. We are addressing this topic and projects for optimizing In this case, about, the optimizing the layout of solar plants, the optimization of offshore electrical generations using windmills, tidal energy generation. We have another project also that is also a regional project, Franco-Chilean regional project with colleagues from Latin America and also from Uruguay, from this university, in which we are developing an autonomous sailboat for sampling the ocean. We have, we are making also part of the system for a drone that detects fires, and if you are reading the news recently, you know that in Chile we had tremendous fires and in this summer, and this is a very key topic as a central trend. And we have a successful project also on detecting deforestation areas from satellite images, and others for doing micro-localized climate predictions, for predicting frost events in fruit plantations, and detecting dispersion of gases of some industries, and the simulation of tsunamis. But this is just to mention a few, the ones that are active today. And there's a big project, this is the one that I will be presenting today, that is in the relationship of applying artificial intelligence to understand the relationship with climate and also the relationship with the ocean, okay? And as I was saying, I will be narrowing down the presentation on the relationship between AI and climate change, and we are very interested in this topic, not only because we are interested in saving the planet, which is very cool, by the way, but also because it offers very good opportunity for our community, okay, to work on this. These problems also pose important challenges to our methods and technologies that we have at hand, and therefore, by addressing these problems, it can make us progress also in the state of the art of computer science itself, and there is like this virtuous cycles that I try to represent here between AI and climate change. So there's a lot of people which is working on this in other communities, ecology, biologists, marine biologists, oceanographers, for example, who have very interesting problems, very well-defined problems, or are gathering a lot of interesting data. This is true, but they are very limited to their capacity by the techniques that they apply. And this is okay. They don't need to have a PhD on AI, or, just for working on this. But just to give you an anecdote, where we started working in this project, I remember that. I was surprised by reading a paper that was in a special edition of Science Journal related to the ocean. And I remember that the paper was very descriptive. It was just saying, it was like the type of, well, this is the data, we analyzed the data, we applied linear regression with default parameters, and these are the results. And it was the Science Journal, the science paper for Science Journal. So this is just to show you and just to emphasize that there is a lot of room for us as community to work on this topic, not only because, again, it is cool and fancy, but also because there is a lot that we can do as community to improve the results that these other communities have, okay? So what happened is that, again, they have very well-defined problems, but they need us as community to come and help and go beyond this linear regression with default parameters, so we can really make the difference by interacting with them. So in this sense, there's a lot of tools, techniques that they don't know, that we are actively developing. Imagine, for instance, all the computer vision results that we are seeing in recent years. So being involved not only, again, is to help to figure out answers and results that make sense to biology, to ecologists, to oceanographers, but also to be able to discover new problems that they didn't knew that they could solve, or even open the door to new discoveries or entire new research lines in their domains, okay? So what I mean is that the interaction with this community, again, emerges the opportunity of actually formulating new questions, because for a lot of them, it's like you have never seen the color red, okay? So you don't know you can paint in red. So what we are doing is just to show them that there's some extra colors that they can use. And for example, causality, explainable AI, active learning, for example, are very appealing topics for this, okay? But then in return, what we have is that, we realize and we discover that actually these problems are very challenging to our methods. They are not easily usable. They are not at all easily addressable. There's a lot of cases where we have small but high-dimensional data that is structured in form of graphs. So we need to use non-trivial methods to address this because there is not only, they don't only want models, they want to solve stuff, they want, models, they want to understand what those models do, okay? And this is, again, very important and very appealing scenario for us. But why ocean? Why ocean, and why the ocean, and why the ocean in the relationship with climate change? So maybe you know this, what I'm going to say now, but the ocean is our main protection against climate change. As it is full of water, the ocean acts like a sort of blanket that modulates the temperature and the variations of the temperature. And there are some interesting data that shows that 80% of marine life is made of microorganisms. Also, roughly half of the oxygen production on Earth comes from the ocean. The majority of this production is from oceanic plankton. This is drifting plants, algae, and some bacteria that can do the photosynthesis. And also the ocean absorbs almost 30% of all CO2 emissions and captures 90% of the excess heat generated by these emissions. So the behavior of the ocean is really interesting because it is even better than the Amazon rainforest. That in the last 20 years, it has been demonstrated that it has emitted 13% more CO2 that it has absorbed. So coming back to the ocean, some part of the oceans produce also CO2, and this is some of the things that we need to understand. But essentially, if we want to fight climate change, protecting the ocean is the thing that we need to do, okay? But what is happening is that also that climate change process is so intense right now that it has overwhelmed the shield that the ocean provides us. And it's actually changing the ocean and therefore destroying at faster pace the protection that we have. So it's not that the things are bad. It's that the things are going bad in an exponential way. So if we want to address this to improve our defense, we need to look at the ocean, and that is why we have created this project, Ocean AI, which is an INRIA challenge in which different teams of INRIA in France, in Chile, in this case, and external teams also collaborate, giving a given goal. It is a multidisciplinary project that is focused on addressing the topics that I just mentioned before. And what we propose to do with this project, with Ocean AI, is to break, in this case, these vicious cycles, not virtuous this way. This time, it's a vicious cycle that I was just describing, that the climate is progressively destroying the healing and mitigation capacity of the ocean. And for that, we need to understand that and to do actions about that, we need to answer 3 big questions, okay? First, we need to understand properly how the ocean mitigates the climate change. This is an open question that is somehow there is strong evidence in biology, but we need to understand and to go deep and understand this process. Second, how these processes are progressively destroying the capacity and the climate change situation itself, and understand what is going to happen to the ocean. For example, if we have an ecosystem of different species, what is going to happen if you increase the temperature of the water 2 degrees, okay? Is this ecosystem going to move to another place, or this ecosystem going to disappear? Anyhow, we don't know, okay? And finally, if everything runs well, we want to answer the question, what to do to protect the mitigation effect, okay, of the ocean. And this is, what we have been dealing in this project. And at the end, what we want is to simulate the scenarios that provide decision makers with the capacity that have, capacity to take actions that have a better outcome, okay? So, as I was saying, the project is highly interdisciplinary. This is a big group of researchers, computer scientists, AI specialists, mathematicians, marine biologists, ecologists, political scientists from different institutions from France and Chile. In the French side of INRIA, we have several teams, Tau, Biocore, Ange. People here that knows INRIA knows that these are the names of the équipe projet, the teams, which are involved in this case on machine learning, in causal inference and modeling side. And we have stronger connections to biology in Chile. We are working with the Center for Mathematical Modeling and also the Catholic University of Chile, in particular with the Department of Ecology. And we have other two key partners, Copernicus and Tara Ocean Foundation, that I will be talking about in a while. Here you have the pictures of the faces of the scientific committee. There's a lot of people in the scientific committee, but we are more than 30 researchers in France in Chile, and it's led by us at INRIA Chile, okay? But you are probably asking yourself, what about the data? Okay, what data do you have? And this is for those methods that you want to apply or create, etc. Well, this is where this foundation, TARA, comes into play. Well, Tara Ocean is a foundation that operates this oceanographic vessel, which is a sailboat, is a schooner in particular, that carries out what they call missions around the world. They have been doing this kind of sampling for 15 years already. And essentially, they sail around the world, they stop in certain parts of the ocean and take samples of the water with the microorganisms that lives in the water. And then they have, this information of the samples, the sample of the water, sequence, and finally they generate these big data sets with all of these informations. But why Tara? Why it's so important for us, Tara? The thing is that Tara not only gathers these samples, but that he has been doing the same thing for 15 years in a consistent way and the same methodological way. Every time they stop and they do what they call a station, is essentially to sample the water, but they do it by sending 3 collectors at 3 different depths. One is at almost the surface, 5 meters, then another 50 meters, where it's supposed to be the peak of chlorophyll production, and one at 500 meters where there is no light, and the ecosystem is a mesopelagic ecosystem. So they have been doing this and have been collecting a lot of samples during the last 15 years. They have stopped at 210 different sampling locations, generating a bunch of genomic information, but they have generated also a lot of images of plankton, because other thing that they do is that they also send a microscope coupled to a camera, and they take photos of the different plankton species that they see. Okay, so and by the way, Tara not only comes with the data. This is very interesting data. It comes also with a big community of people that have been working with this data for a long time, so you can not only interact with the data, but also with the people of this domain that understand the problems, the priorities, and so all of that, okay? So we have some data, we have the team. What's next? How can we split these 3 big, ambitious questions that I said before into smaller problems that we can address and progressively improve the solutions? So, and by the way, well, this is kind of crazy. I will be explaining this a little bit. Sorry about this, but the way, I will be avoiding to use excessive terms of biology to keep the message around AI, and we are relying in 2 main sources of information that we have, images and sequences, okay? So the first question, how the ocean mitigates climate change, is more clear, and in part is already answered by biologists, but in order, to answer this question, we have started to look at how to automatically identify an ecosystem. How can we do that? How to determine and how those ecosystems implement the functions that are that we are interested in, for example, in particular, the capture of carbon. And it's clear that the identification of these ecosystems can be done at the microscopic level, relying on images, microscopic images, and genetic sequences. And the particular case of genomic sequences, we are looking at metagenomes that essentially take samples that include a bunch of organisms. Imagine that you take a cup of soup and put it in a mix and then get 2 little pieces of sequences, and from that you can try to draw some conclusions. So it's more or less like that, okay? So given this, 2 other questions arise, first we can identify those ecosystems using satellite images. It seems that is possible, and this would allow us to go beyond the places where the oceanographic observations have been taken, okay? And second, how to understand the causal relationship between different species. And this is essential, I mean, if we want to implement policies to preserve those ecosystems. For instance, turns out that the whales are essential in many ecosystems. We normally see whales as these big, beautiful animals, I mean, but they are very essential as they feed at a great depth, and then the waste returns to the surface and therefore provide nutrients for plankton in the surface, which are the ones doing photosynthesis and capturing the carbon, okay? I mean, there are evidence also that links, for example, the massive deaths of whales in the coast of Chile with the rise of poisonous algae. So we need to be able to discover these key causal relationships like this, and this is why we are very interested in these problems. And then another problem comes because the ocean is always moving. I mean, so ecosystem moves with it. I mean, you sample one time in this, I mean, in this location, in these coordinates, you can come minutes after that and you don't find the same things, okay? I mean, and this is very, very complex, I mean, because it's not like the Amazon where a tree is fixed to a given location and therefore the animals that feed are also fixed. The ocean is a dynamic environment, and you will see, I mean, this emerging all over during my presentation. And at the end, what we want to have is a model that allows to measure what makes a healthy ocean, because this could serve us to diagnose which part of the ocean are under threat, okay? So the first question is the one that we have most understood, but we already are building the second floor and addressing the question of how climate change is changing the ocean. For this, we need not only machine learning, as we know it, but also modeling. It turns out that we thought that we were departing from machine learning, but I mean, it was a close return because these classes of problem challenges current modeling tools, and the solution is to work on something called physics-informed neural networks. We are currently working on these directions with the goal of in the future to be able to start answering questions about future scenarios, both to understand ocean degradation and to assess actions like take correct degradation, okay? But there is another perspective to this roadmap that is very heavy, which is to look at machine learning methods, the machine learning methods that are already involved. And I will go into a little more detail on some examples later, but we need a lot of zero-shot of few-shot learning, multitask learning, self-learning to be able to cope with the issues that we find in our data, where we have loads on unable data with high dimensions. I mean, and related to that, there are many opportunities also for anomaly detection. I mean, because we need to be able to detect interesting instances out of a mass of relatively homogeneous ones. So the spirit of this project is not just to, again, create models that classify or predict correctly the data that we train on. The idea is also we want to reach out our scientists and policymakers, and we need to understand causality and provide human readable explanation on what we are doing, okay? And similarly, you can guess that fluid modeling is a key part of the project, and given the fact that the ocean is in the permanent change, so modeling tools do not scale up to the challenge of modeling the whole ocean, and this is what we need right now. And this has prompted us to dedicate some effort to develop machine learning-based modeling tools, in particular those as we know as PINs, okay? So what do I mean by small but high dimensional data? Well, first, that the characteristics of the problem impose challenges to AI, the AI point of view, and this is the case of the data, I mean, that we have. We all know that the need for large annotated data suitable for supervised learning limits the applicability and also the adoption of these recent advances, and many practical applications obtaining this data is very expensive, almost plain impossible. So, and these are the scenarios, they are very close to the ones that we are dealing here in the context of the project, because even if for the context of marine biology and maybe oceanographers, Tara has gathered an impressive amount of high quality data. It is not enough in most cases for regular machine learning approaches. For example, to create a tag data set from the Tara data, you cannot just ask volunteers to do the tagging. I mean, as it requires a lot of domain knowledge. And this is why it's crucial to address how machine learning models are trained and adapted to meet this small data scenario. And for instance, we have plotted here all the sampling stops of Tara in the most recent missions to South America and also the Pacific. And we can see that even if it stops a lot, and in every stop, it gathers a lot of data. It is far from giving us a broad picture of the whole ocean. So there's a lot still to do. Therefore, we need, as I said, a lot of active learning, fusion learning, and multitask learning. And we have limited data that has uncertainty and also noise. And we want to help the process of annotation, so we need to direct the annotation process to the areas that provide the highest yield. We can see the same thing for organizing, for example, future expeditions of these missions, for example, of Tara. If we provide them with a map of high uncertainty and highest uncertainty areas, we can make literally more sample efficient in the sense of sampling, of sending the boat to sample. So there are many opportunities in this area, and of course, fusion learning to be able to learn with minimal amount of data, and multi-source, multimodal, multitask learning is essential because we need to assemble different data sets, for example, of different sources of data. We can relate the characteristics of an image, for example, the description of the species, of the DNA of the species. So there are many opportunities here, and by the way, there's a big question regarding transfer learning. At what point what we have learned in one ocean can be transferred to another, so again, every step you take, you find new problems and you find new opportunities to be involved. And just to give you an idea of what, of some of the work that we are doing, and you can guess it by now, we are applying machine learning to understand plankton images, because obtaining plankton images are cheaper than sequencing DNA. Okay, so you can guess that, to get the DNA, you not only need to send the boat and take the samples, then comes a process with the genomic lab, etc. But then in return, it is true that the DNA has a genomic sequence, and in general, it has the advantage that they are shared by species in the planets. Therefore, there's a bunch of information that we can reuse. So this is not the same for photos, unfortunately, or for images of plankton, because plankton does not look like any other thing that you know. So the drawback is that they are hard to annotate because require experts, require biologists to do that, and this is yet another opportunity for active learning. For example, the Ecotaxa repository, that is an open repository for plankton images, contain at the moment 275 million images, more or less, but only 4 million of them are labeled as living organisms. 1 million of them are tagged as non-living, and the other are not tagged at all. So an example of how confusing this is an example of images that extracted in the latest Tara mission, and all of them, by chance, when I tried to do a screenshot of the website, all of them were detritus, okay? So this is not a surprise because the ocean is full of something that is poetically called marine snow, that essentially is detritus. It means that little dead bacteria and animals going to the floor along with nutrients, and that is going to progressively, flowing down to the bottom of the ocean at a very slow speed, and eventually this becomes stone or become a part of the crust, okay. And this is, by the way, how CO2 is sequestered. This is the process. It is processed, it stays in the cell and progressively falls to the bottom of the ocean. So it is not a surprise that we see so much detritus here in the ocean, because it's again full of waste. So one common situation in this domain, as in many other cases, has to do with the bias and unbalance in data sets. And here's an example. We have two of them. So we have the situation, and by the way, if we look at existing related data sets, they are different, but these are the two biggest ones. One is provided by the Woods Hole Oceanographic Institution, and the other is SUSCANS, that is produced by the guys of Ecotaxa, I just mentioned before. So when we look at these two data sets, they are relatively large. They have 4 million images. But if you look at these data sets, you can already, again, smell the problem, okay? If you look at this graph. I mean, this is the amount of elements for each class, and pay attention that the scales are logarithmic. We can see that it's very high imbalance in the amount of data that we have for this class, so it's not the perfect machine learning data set. And if you go into more detail, there are many classes that actually do not represent any meaningful information for clarifying plankton. So there's a big class of detritus here, another that you don't know how to interpret. That is an artifact, probably like pieces of little individuals that if you go to the other data set from Woods Hole Oceanographic Institution, we have elements that are called bad, they are called detritus or mixed. I mean, this is actually the most populated classes. So it is true that these data sets contain a lot of images, but then turns out that we cannot do a lot of stuff and draw conclusions, and at the end just rely on them, okay? So one intuition here is that we need to make progress in understanding what makes an image known or unknown, okay? And for this, we are working in an area of anomaly detection, particularly with out-of-distribution interpretation. There are many methods for doing this. Essentially, I'm going to avoid using a lot of formulas here. What I want to do is that we have a classifier, like it would be any neural network classifier that has an output, a set of logits. And if you inspect the logits, that the results of propagating a regular in distribution sample, they should show that one class should be activated while the others remain inactive, okay? What happens is that when the classifier is faced with a sample that is not covered by the trained data set, it should generate an output that says, I don't know, okay? In particular, that all activations remain low, close to zero, therefore telling us that I don't know how to classify this. So a lot of these out-of-distribution methods looks like this activation pattern of the output of the classifier, applying different approaches. But essentially, they look at this and say, okay, for this guy, it looks like the network does not know how to answer, so probably the input is out-of-distribution input, okay? However, when we started applying this out-of-distribution, we realized that our results were rather poor, and these are the cases when facing real problem can lead you to an interesting, more basic problem. And for instance, we tried a simple idea. What if we show out-of-distribution examples and teach the network how to behave? I mean, when faced with regular in-distribution inputs, then learning goes as normal, and when learning and when inputs in and out of distribution, then the loss function pushes the network to have an all zero output. But there is a point, where do we find these out-of-distribution examples? How do we do that? So, I mean, we said, okay, let's use things that we think that we know that will never happen in the ocean. For example, unknown classes, and we picked, for example, the public flower data set with the idea that they look like biological objects after all. And the results were really good. We raised the out-of-distribution accuracy from 53 to 93% in our test set for plankton images while retaining the same classifier performance. So we managed to teach the network to say, I don't know, even though the network did not see any unknown plankton species. So this is a good result, and it opens the door to future applications where we could use this information to speed up the annotation process even in other domains. So the previous example focused on identifying individuals within ecosystems. Let's talk about right now on understanding whole ecosystems at a time. And for this, we have relied on genomic sequence data sets. We have the advantage that we can make more progress if we use DNA while this result of plankton images get ready. And here, what we want to see using the DNA samples is that if we can go and understand what are the key questions that ecology ask, when they see these marine ecosystems. And these questions, they are one way or another related to ecosystem functioning, and that is, what is the ecosystem good for? And what functions can we observe in this ecosystem? So understanding the processes driving this function is absolutely fundamental for a basic science also and policy perspective, and we are particularly, again, interested in the functions related with the capture of CO2, which one of the main drivers in ecosystem functioning is biodiversity. As you may know, that is measured by the number of species, and the data, the data derived from data and other sources allows to make this comprehensive exploration of the relationships between this ecosystem functioning and biodiversity. But more importantly, for assessing the relative contribution and testing new ones associated to the integration and the variability of these relationships across the different levels of the biodiversity, from genes to species, to traits and functions, and their interaction within the driver variables such as temperature that drive both diversity and ecosystem functions, and with different levels of detail. And for example, for comparing the relationship between the ecosystem functioning and metagenomes with that for metatranscriptomes. So we are doing this, and going back to TARA and the TARA sampling methodology, we have these 3 depths, the TARA that takes samples of the water and then split the samples according to the different sizes of individuals at the microscopic level. TARA has collected thousands of samples, and they are also measure the physico-chemical properties of the water. The samples are then sent to sequencing metagenomes and metatranscriptome. There's a catalog that you can find that it's around 11 terabases of DNA, identifying 42 million of genes, and which is without any doubt a valuable resource to start to make some reasoning. Okay? But the good news is that the nature is robust, consistent, and it is redundant. And this is really a powerful asset that we have in this domain. And so even if we have a very poor data set, or very, let's say, high dimensional data set in terms of amount of features, we still do some work. Okay? For example, we have this data set of 9,000 columns and 200-something rows. If we project this into 3 dimensions, and by the way, this is a work that was presented on Monday during the poster session. Is Luis Valenzuela there? And if we project this into 3 dimensions, we can see that there's a lot of information already present in spite of the huge reduction of dimensionality. For example, in this case, we have colored differently the species that are polar or non-polar. This is what you see in the first plot. You can see a clear separation of most of them. In the second plot, we see how these 3 depths are separated, and we can see that the depth that is green is clearly separated. And in the third case, we can see the zones of the ocean where the sample was gathered and also detected is also very easily appreciated. And this is not at all a final work. This is a work in progress. What we are doing here is like sort of art appreciation, but it's very meaningful because it allows us to even, though we have high dimensional data sets with a lot of features, we can, and few data instances, still there's a lot of work and some work that we can do, okay? But now you're seeing here a small example of the kind of work that we are doing. We started to apply symbolic regression. That is an evolutionary inspired method for doing machine learning that essentially, in brief, allows to symbolic mathematical formulations just by looking at the data. Again, we are interested not only on doing approximations, but to be able to explain them. So we tried to see if there was a relation between the abundances of certain proteins in the sample with regard to some physical properties. So it would be, this would be awesome, because if so, you could go from a given setting of the ocean and try to generate what possible ecosystems could live, defined by different proteins that you observe. So you could then sketch some kind of future scenarios, because if we can say what are going to be the conditions of a given place in the future, we can predict if the ecosystem we have modeled will still be able to be there or not. Okay? And for example, when we group the different proteins by function, we can see that some of these groups of proteins have more to do with the production of nutrients, for example, phosphate, nitrates. This provides a lot of information. We don't have too much time to go in depth with this, but just to give you an example, this is a phosphate, and the phosphate occurs especially at bigger depths in the ocean. So for example, here are all the TARA emissions plot in the map of the world, and the concentration of phosphate in the size of the dots, okay? So we can see them in the surface. There is a very little phosphate, except for the Antarctica. And at the mid-level, there is a high concentration, but at mesopelagic depths, there's a lot of concentration, okay, when we have great depths. And as you can see, almost all samples contain phosphate because it's an indicator of metabolisms that take place in the oxygen-poor environment like this. So I'm running out of time, so I just want to, let me see, I mean that we are also working in this physics-informed neural network. I mean, there's a lot still to say, but I think that is, I'm okay. Let me see, maybe this, or this. I want to say everything. I cannot choose. I cannot choose. Not really. We can still be talking in the coffee or even in the other events at night. Okay. So thank you so much.
I think we have time for one question, a couple of questions. Enzo?
Thanks for the talk, Nayat. Really interesting project. So for the Tara Ocean project, is this like the sequences and the images like freely available, or?
They are freely available. In fact, I need to show one last slide. I'm very sorry. Thanks for the question. With the links and all of that. Just give me a minute. Just give me a second. Okay, yes. I didn't see anything, sorry. So, it's freely available. In fact, we have been working, I mean, besides doing research, we're consolidating and making all of this available, not only to the public and the audience in general, and the results and efforts that we are doing. For example, we have a lot of repositories within the data information that you can use. We have, a cloud platform that you can easily, from Jupyter Notebook, access all the genomic information that we are using. The same for Plankton image that we have, and the machine learning friendly, library that we have developed where you can train your models. This is also available. And I think that one interesting way to interact with it is to take part of the competition that we are organizing in the International Joint Conference of Artificial Intelligence this year. And I recommend you to follow the links and follow all the information. That's it. Thank you.
The question is regarding the genomic data. Are you working with genomics and transcriptomics or only with genomics? Okay. Okay, great. Thank you.
Okay, so before you leave, we have a few remarks. So, Enzo.
Yes. Okay, so a couple of announcements. First, about tomorrow. So tomorrow is our last day. You have to be here at 8:30. Oh. It will come back. It's our last day. You have to be here at 8:30. Last day, okay? We'll have 2 parallel sessions at the beginning, but I wanted to show you what's going on. Because there was a small change on the rooms. Okay, now it disappeared. This one should, no. Okay, there we are. So there will be 2 parallel sessions at 8:30. In the main auditorium, we will have mathematics of machine learning, and upstairs, not in the same room that we had today, but in the other one, B23, there will be a machine learning for health applications parallel sessions, so 2 really interesting parallel sessions. And then after the break, we'll have the parallel session of applications of machine learning upstairs. This was swapped now, so if you look at this is the correct version, okay? Before it was different. And so applications of machine learning, where there will be interesting talks from industrial applications of machine learning for some really interesting companies. And then we have the machine learning education in Latin America roundtable. This will be a roundtable with professors from different Latin American countries, where we'll discuss the opportunities that there are there for students here in Latin America, challenges, future projects, and this will be really interactive, so yeah, to hear everyone. And then we'll go to the Teatro Solís, and the photo that I was telling that is today, no, it will be tomorrow, and I think it will be around that time. So come, you know, with a nice, yeah, with sunglasses. And then, well, and Teatro Solís will be amazing, and we'll have Peter Narvik closing the door, and we'll have 2 amazing round tables as well. So, or 3, actually. This is for announcement, and then also today we have the Women in AI event. I already seen pictures. It's a really nice place, so make sure to attend. There is a question. No, 10:30 both. Where did it say 11? Okay, sorry, no, both are at 10:30. Oh my gosh, yeah, no, both says 10:30. Thank you for the question. Yeah, we will correct, but I think in the website is okay. This is just our slide. Yes, so group photo tomorrow. Buses now will be leaving at 6:30 from the Dazzler Hotel. For those who are not there, you just Google map it, and it's not far from here. And don't forget your badge. This is important to get into the event, okay? So bring it to the event. And that's, sorry? Mini badge gradient design. Thank you very much.